wanna sleep. I got the sheets on the floor, nothing on me. And I can't take any more, it's 100 degrees. I got 1 foot out the door, where are my keys? Cause I gotta leave there, in the back of the cab. I tip the driver ahead of time, give me the best. I got your body on my mind, I wanna bet. Ooh, just the thought of you gets me so high, so high. keep this love in a photograph. We made these memories for ourselves, where our eyes are never closing, hearts are never broken, time's forever frozen still.
So you can keep me inside the pocket of your ripped jeans, holding me closer till our eyes meet. You won't ever be alone. Wait for me to come home.
Loving can heal, your loving can mend your soul, and it's the only thing that I know. I swear it will get easier. Remember that with every piece of you, and it's the only thing we take with us when we die. We keep this love in this photograph. We made these memories for ourselves, where our eyes were never closing, our hearts were never broken, and time's forever frozen still.
So you can keep me inside the pocket of your ripped jeans, holding me.
Okay. Good morning, all. So welcome to Portugal. Welcome to Artnovion event. I hope you find you well. It's all good. So, I need to read. I'm an engineer, so I don't give too much speech. So today, distinguished guests and colleagues and friends, it's an honor to open this event and to welcome all on behalf of Artnovion team. I find it easier to design a product than giving a formal speech. Sorry, guys. But today is special. So today we celebrate an important milestone. And this is how we like to celebrate. By bringing the very best on stage and by gathering our worldwide professional family. Thank you guys for coming. So, we prepare a full day of inspiration. And the day we hope will help us keeping moving forwards, united by one thing, our passion for acoustics. So let's embrace these new ideas, share our experience, and shape the new frontiers of acoustic all together. Thank you, guys. So I hope you have a wonderful day. So, Tiago.
Good morning, everyone. My name is Tiago Branco. I'm part of the Artnovion R&D team, and it is now my great privilege to announce the initial panel of this conference, Advancements in Iterative Optimization of Critical Listening Rooms. Please welcome to the stage Dr. Peter D'Antonio, PK Pandy, and Artur Zorzo. A round of applause.
Good morning. Well, thank you, George, for the invitation. And I'm happy to be here at this lovely, lovely place. And I've been in this business for many years, 40 years. Started RPG in 1983. And when I sold RPG in 2017, I wanted to get back into my research into critical listening rooms. And so I started collaborating with John Storick, who was a friend and a client of RPG for over 30 years. And we began looking at rooms that are not cuboid. So this is a rectangular room. Many of the projects that are critical listening are not rectangular. They have an alcove or they're non-parallel sides. And we started working on expanding a piece of software that I created many years ago in the late 90s for non-cuboid spaces. And as a result of the initial research that I did with John at WSTG, Rinaldi Petroli was an intern then, and we started working together. And the first thing we developed was a piece of software which we call Nero, the non-cuboid iterative optimization for rooms. And with the success of this, we decided to start a new company called Ready Acoustics. And PK was a founder. He's here. And later on, Arthur joined us, as well as the other people that you see up on the screen. After developing Nero, which I will describe in detail, we then published a few papers about it. And then after we optimized the room and the position of the loudspeaker and listeners, we then needed to develop an optimization software that found the ideal acoustical treatment for every accessible area in the room. And we called that the Treatment Optimizer for Room Acoustics, or TORA. That's in 23. So those are optimization services that we offer to the design community. We operate in the background. Design team brings us on to do this optimization for their critical listening rooms, and we issue a report to them. In many cases, the report is in their name. And then we recently, in 23, introduced two commercial apps that are online. You can see them on our website, and PK will describe how they're available to vendors across the world. And the first was an evolution of the Room Optimizer that I designed in the late 90s, and it's called the Room Optimizer for Cuboid Spaces, or ROCS. And then we developed an acoustical treatment calculator, which we will also describe. So these are optimization services that we provide. Those are commercial apps that you could find online. So to begin the presentation then, I'm going to talk about what acoustical distortion is, what objective measures we optimize, and then the Nero and TORA optimization capabilities, and then ROCS and the acoustical treatment calculator. And at some point, I'm going to talk about a new working group that I've formed called the Boundary Admittance Measurement Method Working Group. We have, I'll describe it to you in a bit. And then there's another new capability. We created a virtual goniometer. It's a big word. I'll describe what that means. And then Arthur's going to come up and describe the the success that we've had with over 100 projects using this software. We're only going to focus on 7 of them at the moment. So to begin, what we're focusing on are what we call critical listening rooms. These are rooms like recording studios, home theaters, audiophile listening rooms, and it even expands to podcast studios, to almost any space in which audio is involved. And so here you have a recording studio and a home theater, and what we like to say for the production rooms, these rooms need to be transferable. What I mean by that is when you're creating a musical product, you need to be in an environment that is neutral. In other words, the environment should not be contributing to what you're hearing, because if it is, then you can't take that product out of the room. So I came up with an expression many years ago: if you can't take the room out of the mix, then you can't take the mix out of the room. And the same thing for a reproduction room. If you can't take the room out of the music, you can't play back the music in the reproduction room, because you're not really hearing what the original intent was. So now, in order to create a neutral environment, you have to remove the acoustical aspects of the room. And in order to do that, you have to remove these potential forms of acoustical distortion. And I'll talk to them about those in a moment. The one thing that I wanted to mention is that the sound that you hear in a room is influenced by the interaction between many things, namely the shape of the room, the size of the room, and the boundary construction, the mass and the stiffness of the room boundaries, because they are acoustical treatments, and you need to be aware of that. And so at high frequency, what you're mainly hearing is the sound from the loudspeaker. Unless that sound is corrupted by early reflections from the walls, the floor, and the ceiling, and the furniture. As you go down to lower frequencies, then what you're hearing is primarily dependent upon the modes in the room. Modes are standing waves that get set up between room boundaries, and the decay of those modes. So when you have a room mode, it actually decays over time, which results in reverberation. And so what is important to know is that the position of the source determines which modes are energized, and the position of the listener determines which of those modes you can hear. And you'll understand that a little better. So if we can go back to the forms of acoustical distortion, it's mainly the room modes. The speaker boundary interference is the coherent interference between the low frequency driver and the surrounding surfaces, the nearby surfaces in the room. And that can only be controlled by the position of that speaker. Then as we get to mid and high frequencies, you have cone filtering, which is the interaction between the direct sound and the delayed reflection from nearby surfaces. That causes what is called cone filtering. It's called cone filtering because in a linear frequency, it looks like the teeth on a cone. And then you have the early reflections. What we try to design a room to be like an ideal concert venue where you have the direct sound. Do I have a pointer? You have, yeah, I guess that's a pointer as well. Well, I can point. Where you have the direct sound, then the early reflections, this is the time, and then a very diffuse background. A very diffuse background. And we create this diffuse background that does not have these isolated reflections using diffusers. A diffuser is a device which scatters sound. So then, on the next slide, what I'm going to describe now is what we call the objective measures or the potential problems. Okay, so we want to make sure that the low frequency response, this is up to 200 hertz, is as flat as possible. Because there's been a lot of psychoacoustics research which indicates that a flat response is an ideal response, as you can imagine. But the room has these interfering problems. This is a mode at 40 hertz, and you have other problems that we need to reduce. Now, what I'm going to describe, these potential metrics, we need to optimize them simultaneously, because we don't want to make one better at the expense of any other. And that's where we have a very powerful software called a non-dominated sorting genetic algorithm, in which we can look through hundreds and thousands of possibilities where we optimize all of the objective measures simultaneously without penalizing any one for the benefit of the other. So the first is to make the frequency response at the low frequencies. The low frequencies are the biggest problem in a room. And this is the initial focus that we worked on. The next objective measure is reflection control. So here we have the direct sound, and then you hear the reflections because sound travels at a finite velocity, so you get a reflection from the wall at a little later time, reflection from the ceiling at a later time. Eventually, the rear wall reflection comes in, and so we need to first operate on this region here between the direct sound and the rear wall, and we call that the reflection-free zone. In large room acoustics, it's called the initial time delay by Leo Baranek. Once we optimize these reflections below the threshold before those reflections interfere with what we're hearing, then we want to create a diffuse sound field with acoustical diffusers that I will describe later, to be as uniform as possible without individual reflections which interfere with the spatiality of what we're hearing and the frequency of what we're hearing. So we need to stay below these thresholds, which are really important, that were determined from psychoacoustic research. So the next objective measure is the temporal decay. So when you have a room mode, it will decay over time, and that's essentially what leads to the reverberation time. And so, excuse me, this is some work done by Bruno Fazenda, which I hope he was here, and hello, Bruno, virtually. I wish we could have met you. This is a very important psychoacoustics piece of research in which he found the threshold for artificial sources and then for music. And we need to stay below this decay threshold before the room modes interfere with what we're hearing. And lastly, we have the reverberation time, which is a parameter that most people are familiar with. And we need to keep the reverberation time within published standards. This is the upper level. You see the reverberation time is allowed to increase at low frequencies. And so in our research, we optimize all of these objective measures simultaneously. That's a really important factor. And so on the next slide, this describes how we do it. It's basically a hybrid approach. So this is the pressure zone below the first mode, which nothing much is done with. But once you get past the first mode in the room, in order to address the low frequencies, you have to use what is called wave acoustics. And wave acoustics is an approach in which you can calculate the frequency response. There's also an advance in which you can calculate the response in the time domain. But we're using a finite element method, or called an FEM. We started with a boundary element method and evolved into a finite element approach. And what you're seeing here is the pressure variation within the room. And so we address the low frequencies with a wave-based approach. In the mid-frequencies, we use a stochastic ray tracing. What that means is that you send thousands of rays into the room and you follow their path over time to create a time response. And then at high frequencies, you can also use what is called an image model. And we'll describe what that is. An image model is useful. That's the model we used in the first room sizer that I created with Trevor Cox at Salford in the late 90s. And we'll describe that in a bit. But this is the hybrid approach that we use. So to begin with, to address the low frequencies with a finite element method, we receive a drawing from a potential design firm. It could be an architect, it could be an acoustical consultant, and in many cases, it's an acoustical consultant. That's our primary collaborator. We receive a plan view in a section. From that, we create our computer model. What the computer model is we define these vertices. Every plane has 4 vertices, and in many of these rooms, we determine the vertices of the ground plane, and then grow that vertically to create the room. And so in our optimization, excuse me, what we're doing is we are optimizing the position of those vertices which define the planes. And to do that, it's a very complicated process. You have to first mesh the boundary of the room. These mesh elements are typically triangular, but they can be different geometrical forms. And these intersecting triangles, they're called mesh elements. The size of them is determined by the upper frequency. Okay. And so we mesh the boundary of the room, and then we mesh the interior of the room, and then we have to also mesh acoustical products that are suspended from the room. The next slide. This is the stochastic ray tracing, where we follow these rays throughout the room, create an echogram, and then eventually add a phase element through a Hilbert transform for each element, and then we combine all those elements to create an impulse response for the room. Okay? And then at high frequencies, we can use the image model, which also can extend to low frequencies. And to do that, we use that initially to find the first reflection points. Okay. So here is the problem. We then combine the low frequency response with the geometric acoustics, the stochastic ray tracing, combine those all, transform back into the time domain to create an impulse response. And we can use that impulse response to listen to the room. It's a process called auralization. So we combine that impulse response with either an acoustic anechoic signal or a non-anechoic signal to listen to the room. So the first process is for us to meet with the client, and we have what we call a kickoff meeting where we learn what the goal of the project is, what the speakers are, what the acoustical constraints are, what the architectural constraints are. In other words, how large can we make the room? How small can the room be? What are the areas within which we can locate the speakers and the listener? And we go forward with the optimization and eventually provide a report. So this is the non-iterative room optimizer, where we optimize both the boundary, volume, the listener position, and the loudspeaker position, okay? And here's what the challenge is. Given a room geometry, given a physical room geometry, we have to locate a sweet spot for the speakers and the listener. In other words, where in this room is there a pressure that is uniform at all frequencies? It's almost an impossible task, which is why you have to optimize all the objective measures simultaneously. And so on the next slide, I'm just going to briefly explain what is traditionally done. What is traditionally done in a cuboid space is you optimize the dimensional ratios. Like, what is the ratio between the length, the width, and the height? And the reason that falls apart is because there's a lot of assumptions. The room has to be cuboid. The surfaces have to be perfectly reflecting, like this wall is. And all the modes have to be excited. And that's the calculation of the frequency response that you get from using this formula, which is a solution to the wave equation for these rectangular rooms. But what happens is, when you place the speaker in the opposite and the listener in opposite diagonal corners, you get a frequency response which doesn't really resemble that in very much. And then when you introduce the speakers and the listeners into the room at realistic positions, the frequency response is completely different. So it might be appropriate for some spaces, but not for all spaces. And so what Nero does on the next slide, as you can see, we're optimizing the shape of the room within the constraints of the architecture, the position of the loudspeakers, and the position of the listener within an area, because when you're listening to music, you don't have your head in a neck vise. You're moving left to right, up and down. So we try to optimize the frequency response over a region. We call that the spatial variation. So here's the frequency response. This is the variation in light blue with position. And then these are the early reflections that we want to minimize in the reflection-free zone. That was our first development. Then, once you have optimized the room and the positions of the source and the listeners, now you have the opportunity to introduce acoustical materials. And so we had to develop another module, and this is a very difficult challenge, and we call that the treatment optimizer for room acoustics. And on the next slide, you can see what it does, and I'm going to ask Arthur to describe this. Arthur was responsible with the other members of the team for the coding of this module. So Arthur Zorzo.
Just going to try to explain a little bit of how this works. Usually we get already a design intent from the client, so we already know what he wants to see in terms of treatment, how the room should look. So we already know that we are going to have diffusers on the back, some treatment on the sidewall, some treatment on the ceilings. Then we adjust our digital model to have all those treatments. And then what we are going to optimize is what those treatments should be doing, at which frequencies they should be acting. So basically here we have millions of possible combinations, and our goal here is to find that perfect treatment set that's going to improve all of our metrics. So the frequency response, we want to minimize that spatial variation. We want the temper of the decay to be as low as we can get, and the reverberation time to be inside the limits that are defined by the standards. Or if the client has another target for the RT in mind, we can also adapt for that. So here you can see in this animation a really interesting room because we can clearly see that we had an issue around 130 hertz, and you can see that in some of those rooms, that issue is actually solved. So this was very eye-opening to us because before this we were doing a little bit, I would say, by hand. So we are all acoustical engineers in this company. So if we had an issue at a certain frequency, we would design a treatment and try to place it in a particular position of the room. But since we got this to work, was like night and day. We got results a lot faster, and we got way better results with more consistently. So this was something that was very, very important to us, and is a very powerful tool that we use nowadays to get that perfect treatment set that's going to improve all we need to see in one of those rooms.
Arthur. So now that we've... Yeah, this is all predictive. In other words, what we're trying to bypass is having a client build a room, and then find out that they have some problems, and then find some acoustical treatment to deal with those problems, or try to do it even less effectively digitally. And so when we're involved in the project, we predict the performance of the room, and we have measured some that we will describe in which our predictions match the measurements. So those are the two optimization tools that we provide to the design community. Now we're going to talk about two apps that are available online on our website. The first is the Room Optimizer for cuboid spaces, and what that enables you to do is to input your room, input the length, the width, and depth of the room, because it's a cuboid space, and then the software allows you to evaluate your room. In other words, know your room. So you're looking at the low frequency response, you're looking at the spatial variation, you're looking at the pressure distribution throughout all of the frequencies, and you're looking at the early reflections to know where to place acoustical treatment. And then once you have the room optimized, the geometry and the location of the speakers and the listener, I keep saying that over because you have to do that simultaneously. Then you have the opportunity to introduce acoustical material. And so this is an opportunity for us to collaborate with Artnovion. These are just products that I have developed throughout my career. Porous absorbers, perforated panels. We have a new low-frequency absorber, and then sound diffusers. And these are different packages to address, and the package changes depending upon what the software indicates of what you need. And then, see the next slide is, so in order to determine what these products do, we have to both predict them. We use a transfer matrix method, but I also have a low-frequency tube that I've had for over 30 years that measures between 20 hertz and 200 hertz. We can even go down to 8 hertz on some occasions, and we can compare the prediction with the measurement. We also have a reverberation chamber to measure the absorption coefficient at higher frequencies. And then on the next slide, this is just a description of our low frequency. It's a tunable absorber, as is Artnovion's product, where we have a passive radiator. This is where the voice coil would normally go. And what we do is we measure the absorption of the unit as it exists, and then we can add weights to the to the dust cap to get absorption at these various frequencies. And once we know the absorption versus frequency, we can design a weight for any frequency. So if the software says you have a problem at 90 or 45 hertz or what have you, then we can determine what the weight is. Okay, and so PK is going to describe how this software is available worldwide.
So we wanted to make this available to the masses. We understand that probably 99% of the rooms out there are cuboid spaces. They don't have geometry with them. They're not control rooms, and they're not intended to be control rooms. It's mostly a bedroom studio or a hi-fi listening room or a home theater of that sort. So with Rocks and the ATC, which is available now through our website, through a web app, through a subscription model of $99 a month, or it's available through a network of 1,500 online and brick and mortar retailers that are out there. You can buy this model from them. And we're also thinking about making it available to all you people as well.
Thank you, PK. So let me explain now what the problem is with the room itself. We have coefficients for the absorption coefficient, for the scattering coefficient, for the diffusion coefficient. And I've worked on standards groups for countless hours to determine the standard for the diffusion coefficient and the scattering coefficient. Diffusion coefficient says how uniform the scattering is. Scattering coefficient says how much energy is scattered into non-specular directions. Okay? And so, but what we don't have is a description of the room's boundary. Okay? The room's boundary is determined by two values which are related, the impedance, which is a complex term, and the reciprocal of the impedance, which is called the admittance. And so in order for us to do what we did, if you can go back one more time, we basically configured a room with a boundary that we see a lot in recording studios. Double layer gypsum, plywood, double layer gypsum. And so experimentally, we determined the admittance that agreed best with the low frequency response. And this was an admittance of roughly 0.02. It varies. And so we wanted to develop a working group, an acoustical standards working group, to determine the boundary admittance of a room. This is not a parameter that exists right now. Okay, so the first informal meeting we had was at the Acoustical Society in New Orleans. And fortunately, we had members from around the world, Trevor Cox, Keith Attenborough, Christian Naki, and you could read the names. And we put together a preliminary set of methods to utilize. On the next slide, you can see we have the scan and paint by microphone, the SoundCat, which is a spherical microphone with 8 MEMS, a spherical array with 8 MEMS microphone. This is some work I did years ago using calculating the impulse response at many positions along a surface at different levels from which we can extract a lot of acoustical information. And then a portable impedance tube, which is attached to the wall. And lastly, one of the things that I was proposing, what happens is some of the standards that are created in my world, the scattering and diffusion coefficients, we spend a lot of time developing them, but they never get picked up by commercial laboratories. So commercial laboratories are not measuring these parameters. And so I had to create a piece of software to do that. But for this purpose, I was proposing that we measure the boundary admittance, whatever that method turns out to be, in the source room. This is a method, a standardized method, ASTM E90, in which you measure the transmit. Oh, I'm sorry. I'm good. The stage end, the transmission loss of the boundary. I do these things occasionally, and so you have a source room and a measuring room. And so what we wanted to do is we wanted to make that measurement in the source room while we have that boundary construction in place, rather than having to build it every time we wanted to measure what it is. And so that's another possibility. On the next slide is the first results we got from the microphone scan and paint, in which this is a PU microphone that they've measured in several locations, and that's the average response. We're still figuring out what to do with that. So anyway, if you're interested in this, you're welcome to join the working group. Just let me know, and we could put you on the mailing list. The next meeting of the working group will be in Hawaii at the Acoustical Society meeting. I have a presentation there with Michael Forlander in which we will describe the status and what we do in the future. Okay, so on the next slide is the second part of the app that we have available. There's rocks, and then there's the acoustical treatment calculator. Now, the acoustical treatment calculator is essentially the transfer matrix method, but in a very convenient form for you to use. And Arthur has worked on this, and why don't you briefly describe this, Arthur?
So this is also an app that's available on our website, so you can just go in there and make a login and purchase a license to start using. So basically, you can predict, thank you, the absorption of all those treatments, a multi-layer treatment. You can also get the impedances. You can download the results in an Excel spreadsheet where you can use those values to use with other softwares. And it's a very interesting tool, very easy to use. I'm going to talk a little bit more about this later, but later on we are going to make a few demos of rocks and the ATC, so come to us if you want to see how it looks. We are also going to make available some free licenses to this software. So whenever you have the time during the day, come to us and we can show all of this working and how it works.
Thanks, Arthur. So the next topic of discussion is what acousticians need are these acoustical parameters, absorption coefficients, impedances, and what have you. And for especially in a geometric model, like in the stochastic ray tracing model, you have random incidence absorption coefficients and scattering coefficients. Now, scattering coefficients are not really available yet. There's no table at the back of somebody's book that you could look up what the scattering coefficient of a surface is. And so since it's not available through measurements, through the commercial laboratories, we created a piece of software which is a virtual goniometer. In order to measure the diffusion coefficient or the scattering coefficient, you have to measure the polar response of how a surface scatters. And so on the next slide, you see this is a virtual goniometer. These are 13 sound sources which arrive at the sample at various angles of incidence. And these are 4,000 microphone positions which measure the scattered radiation, the backscattering of this incident sound from the surface that you're trying to evaluate. And so we're using an FEM program that uses what is called a, excuse me, a perfectly matched layer, which is the red line, and it's a very elaborate program which allows you to create the polar response from which you can calculate the diffusion and scattering coefficient. So this is the ability of, this is an app on the RPG website which allows you to choose any number of parameters, any number of surfaces, and the angle of incidence, and look at the polar response. So this is the polar response from one of the samples, and all 4 samples are evaluated there. Now we're going to be incorporating a portion of this into our acoustical treatment calculator, which is why I'm bringing it up now. And I'm also bringing it up because last time I met with George at the CEDIA meeting, we discussed maybe evaluating some of the diffusing surfaces that Artnovion has created. And this is a capability that you're going to be able to do that, because coming soon, you'll be able to go to the website, upload your drawing of your product. And this is really important for acousticians and architects, because in many cases, an architect will come up with a shape. Architect had a dream of a certain topology that he wants to see in the space. He presents it to the acoustical consultant, and the acoustical consultant really, prior to this point, has no way of evaluating how well that surface will perform in the space. And now he has that ability, because he could upload the topology, calculate the scattering coefficient, so he has a piece of evidence now to present to the architectural team. And so if you're interested in that, see me. And now an important part of the presentation is for us to present the projects that we have actually, some of the projects, 7, that we have predicted and measured how well they agree. And Arthur's going to go through these 7 projects.
Okay. Okay, guys, so we have all those nice tools. We have the FEM, the ray tracing. We have all those optimization methodologies to use. So how do we know that it actually works? So by now we've optimized, I think, hundreds of rooms. And whenever we have the chance, we go to a finalized room and we measure the whole room to be able to compare with our predictions, okay? So here I'm going to present 7 rooms, but we have a database of dozens of rooms where we actually made the measurements to compare with what we had in terms of prediction, okay? So here is the comparison between the low part of the frequency response on the left of all of those projects, and on the right you can see the error between those 2 curves. And we can see the trend is definitely there. The matching is quite good. Obviously, sometimes you have some misalignment in a few frequencies, then the error gets big. And the methods are also not perfect, so this is something we also have to take into account. And usually there's something that we never know at the stage where we are working, which is the furniture that's going to be added to the room afterwards. So usually the client adds a couch, some tables, even instruments, keyboards, and so on. So this is also something that's going to make our simulations deviate a little bit from the measurements. But we are getting some really good agreement from those predictions, and the clients are all very happy. So this would be for the frequency response. For the reverberation time, we also usually have really good agreement. The maximum error that we usually get is around 0.1 seconds, which we believe it's very good for the situation. And as you can see on the left, usually our simulations are a little bit higher than what we measure. Yeah. And we also believe this is due to all the furniture that's going to be added, the couches and everything, because that's going to change the volume of the room. It's going to add diffraction and absorption and so on. So now I'm going to talk about one of those cases, which was a very interesting room. It's called Hugh Boyer Studio A in Paris, France. And this room was very specific because it was supposed to be a control room for mixing stereo and Atmos, but also it doubles as a live recording room. So you can see that the console goes away into the ground, okay? And it's also a teaching room. So students would come and they would have a lecture with a mixing engineer to try to learn as much as they can from them. So what we had to do here was to make sure that the response was consistent all over the room, to make sure that the students could actually hear the same thing as the mixing engineer. So this was actually very challenging. And to do this, we had to use our optimization capabilities with what we did was we actually used an array of subwoofers, okay? So we had 2 subwoofers on the speaker roll on the front, but we also had 3 subwoofers on the ceilings, on the sides and on the back. And by doing so and combining with all the optimization that we had for geometry and treatments, we actually managed to get a very good response throughout the room. And when you get there, you can really feel this, that if you go to the back of the room, which is usually an unusual situation, the response is just as good as in the mixed position. Now I'm just going to explain briefly what we do in terms of treatment and how we present those results. So basically, we try to be very detailed with this. Most of those rooms, those high-end control rooms, the treatments are built on site. They're not panels that you buy off the shelves. So we try to be as detailed as possible over which surfaces we are using as treatment, the position, the surfaces, the area, and also exactly a recipe on how to build them. Okay, so we try to be very detailed with that to make sure everything goes great in the final result. And then a little overview of every treatment that you had in the room. For this room, we had 17 treatments, but this is just because they are all built on site, so they have slightly different depths and everything, and then we have to simulate them as different treatments. Now I'm going to switch back to Peter to talk about the diffusers.
So one of the things, when I talk about creating a uniform diffuse sound field, like you would have in a performance space, where you don't have any individual reflections that are arriving late in time, originally in 1983, we developed the first quadratic residue diffuser. And it was really important at the time, but it's like any other device. It has a frequency range in which it operates and frequency ranges in which it doesn't operate. So we then went through several optimization capabilities of introducing a diffusing fractal, and then these quantized well depths from number theory have their own limitations, and so we developed a surface that does not have quantized well depths. And then eventually we introduced these high-frequency diffusers inside of a low-frequency diffuser. And so this is the ultimate evolution of number-theoretic diffusers, in which once we optimize the non-quantized well depths, we optimize the surface so that it's non-symmetrical, like your hand. And what happens is, even if you have an ideal diffuser, if you put an array of those on a wall, you basically degrade the performance because you get scattering in very specific directions that is determined by the size of the unit. And so what we had to determine a way to take a periodic surface and make it non-periodic, or the word is aperiodic. And so if you take a diffuser, the plus and the minus down here mean that, so you have an ideal diffuser that is asymmetric. And then you have to find a way, instead of just mimicking that like a fleur-de-lis pattern on a wallpaper, you can basically rotate that. So you see that some of these have a plus sign on the left and some of them have a plus sign on the right. And so what you do is you take this surface, and based upon an optimal binary code, you flip it. So you'll have a 0, a 0, a 0, and then a 1 and a 0, whatever the code might be. And so this was the first time we had such a large array in the back of Rue Boyer. There's maybe 9 diffusers back here that you see here. So that was in what we have done, that was the most elaborate diffusive treatment that we introduced into a space. And it's useful because, like Arthur was saying, the room is used for speech, for teaching, for a whole lot of different things. And we utilize the boundary below the console. You notice that the console went up and down. We utilize that air cavity when the console is up in the recording studio position. We utilize that really deep cavity to provide low-frequency absorption. And if you happen to notice when, well, you'll see it on the next slide, the low-frequency response is really excellent way down in low frequencies. And Arthur can take you through the rest of these slides.
These are the comparisons between both speakers measured separately of the room, so we can see good agreement. I don't know if you can actually see the pictures up there, but there are a lot of things there we didn't know beforehand. We have a couch, we have keyboards, and we have everything. And even so, with all those things added to the room, we still got a very good agreement in terms of low frequency response. Also in terms of reverb time, so around 0.1 maximum error here. And also in terms of temporal decay, so we have a very nice match between what we predicted that the temporal decay would be and what we actually measured in this room. So this was a very interesting room for us, very difficult room to optimize, but in the end we got great results, and the room there sounds amazing. Yeah.
So really, to summarize, what we are trying to present is the fact that we are trying to optimize the room before it's built. Okay? Instead of going through all of that effort of building a room and having to rebuild it and introduce acoustical material, to our clients, we present a optimized solution to the room before it's built. And then the two tools, the ROX and the ATC, which Arthur will demonstrate if you have an interest, at lunchtime or maybe later, to go over the details of those. And so we wanted to leave some time for questions, and so we have like 4 minutes left, and we'd be happy to answer any questions you might have. Yeah. Right.
Taking from the studio, you mentioned that the back part of the studio sound as good as the front part of the studio.
Right.
So you guys are breaking down the barrier where the sweet spot is all over. Is that the correct affirmation, or we do still have some difference? Because that's my understanding
Yeah.
now. We are like we're starting to see something that sweet spot is just all over the
Right.
place.
Well, especially in a home theater where you have, maybe 3-4 rows of 6 seats, your sweet spot is not where the engineer sits. So that's why we have this thing called the spatial variation. So we will optimize. Obviously, there's going to be one spot that's a little bit better than others, but the idea is to have the ability now to widen that sweet spot. And so that's a good question.
You'll see in the Rocks demo where you can have, 10 points of listening up to 127 different points of listening. So we're expanding that across the room.
Yeah. In other words, you can define that area.
And that combined, that sweet spot combined with the basically passive balancing that we're doing with these treatments, give you a very, very balanced response throughout the whole room without any hot spots.
Thank you so much. That's groundbreaking.
Thank you.
Thank you.
Go ahead. Oh,
Is there any active speaker processing being used in the commercial studios? I guess it's not an issue for hi-fi, but in the commercial studios, is there any active speaker equalization used in those projects or not?
Yes, there's lots of DSP processors being used to do active calibration. And that's not only, we've minimized that work to where you don't really have to do so much carving and shaping of what's going on. And also in Rocks, you'll see, which we didn't mention, is that we have a whole library of speakers. So you can choose your monitors and put them in there and see how they're going to behave in the room. You see what kind of results you're going to get. But to speak to your point, yes, there's lots of different active calibrations used. And not so much to flatten the room, because that's not the best experience that you're going to have when you're mixing music and listening. You want to do it to taste. It's just to, give the best response to your taste for your listening experience.
yeah, that's
Okay.
what. Go ahead.
Sorry to interrupt you. It will be a round table, and all those questions will be them joining, and then a round table, and also, more speakers. So, I hope you do understand. Then we have the schedule on time.
Yeah.
Okay. Sorry to interrupt you. So we do later on the round table all the questions.
Okay.
To be continued.
That's fine.
To be continued. Yeah.
Thank you.
That's it. Thank you, guys.
Peter, PK, and Artur, thank you very much for your insights, for your expertise, research. Thank you very much for joining us. I'm sure a lot of people will come to you by the coffee break for sure, so we'll have time for that. So before we continue, let me take you to what is next, what's coming next. So here goes.
Artnovion always care about innovation, and not only on technology but also in materials. We have some examples here. This is mycelium. This is made of mushrooms, and it's a very sustainable solution. This is a recent material. It's called hemp. Here we have a limp mass made out of cork, and we are trying to use this to create like a membrane. So maybe in the future we have a bass wrap with cork. We are trying to have more sustainable solutions, more natural, from different types of materials that you can find in the nature.
Yes, advanced materials. Yes, it is. So, for those who don't know me, my name
must think that I'm a fool. You must think that I'm new to this, but I've seen this all before. I'm never gonna let you close to me, even though you mean the most to me. 'Cause every time I open up it hurts. So I'm never gonna get too close to you, even when I mean the most to you, in case you go and leave me in the dirt. But every time you hurt me, the less that I cry. And every time you leave me, the quicker these tears dry. And every time you walk out, the less I love you. Baby, we don't stand a chance. It's sad, but it's true. I'm way too good at goodbyes. I'm way too good at goodbyes. I know you're thinking I'm heartless. I know you're thinking I'm cold, but I'm just protecting my innocence. I'm just protecting my soul. I'm never gonna let you close to me, even though you mean the most to me. 'Cause every time I open up it hurts. So I'm never gonna get too close to you, even when I mean the most to you, in case you go and leave me in the dirt. But every time you hurt me, the less that I cry. And every time you leave me, the quicker these tears dry. And every time you walk out, the less I love you. Baby, we don't stand a chance. It's sad, but it's true. I'm way too good at goodbyes. I'm way too good at goodbyes. No way that you'll see me cry. I'm way too good at goodbyes. No, 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 no way that you'll see me cry. I'm way too good at goodbyes. 'Cause every time you hurt me, the less that I cry. And every time you leave me, the quicker these tears dry. And every time you walk out, the less I love you. Baby, we don't stand a chance. It's sad, but it's true. I'm way too good at goodbyes. Red cups and sweaty bodies everywhere, hands in the air like we don't care. 'Cause we came to have so much fun now. Got somebody here, might be the one now.
If you're not ready to go home, can I get a hell no? 'Cause we're gonna go all night till we see the sunlight, alright.
So la-da-dee-da-dee, we like to party, dancing you and me, doing whatever we want. And this is our house, and this is our rules, and we can't stop, and we won't stop. Can't you see it's we who own the night?
Can't you see it's we who about that life?
And we can't stop, and we won't stop. We run things don't run we.
Don't take nothing from nobody.
Yeah, yeah.
To my homegirls just trying to live it up, shaking it like they can't get enough. Remember, only God can judge us. Forget the haters, 'cause somebody loves you.
Memories till the night's through, surrounded by the ones who love you. We also turn up here, getting turned up, yeah.
So la-da-dee-da-dee, we like to party, dancing you and me, doing whatever we want. This is our house, this is our rules,
And we can't stop, and we won't stop. Can't you see it's we who own the night?
Can't you see it's we who about that life?
And we can't stop, and we won't stop. We run things, things don't run. We don't take nothing from nobody. Yeah, yeah. It's our party, we can do what we want to. It's our house, we can love what we want to.
It's our song, we can sing if we want to. It's my mouth, I can say what I want to.
And we can't stop, and we won't stop.
Can't you see it's we who own the night? Can't you see it's we who about that life?
And we can't stop, and we won't stop. We run things, things don't run. We don't take nothing from nobody. Yeah, yeah. It's our party, we can do what we want to. It's our house, we can love what we want
Can't you
to.
see it's we who own the night? Can't you see it's we who about that life?
It's our song, we can sing if we want to. It's my mouth, I can say what I want
We run
to.
things, things don't run we.
'Cause we can't stop. Heart beats fast, colors and promises. How to be brave? How can I love when I'm afraid to fall? But watching you stand alone, all of my doubt suddenly goes away somehow. One step closer. I have died every day waiting for you. Darling, don't be afraid. I have loved you for 1,000 years. I love you for 1,000 more. Time stands still, beauty in all she is. I will be brave, I will not let anything take away what's standing in front of me. Every breath, every hour has come to this. One step closer. I have died every day waiting for you. Darling, don't be afraid. I have loved you for 1,000 years. I love you for 1,000 more. And all along I believed I would find you. Time has brought your heart to me. I have loved you for 1,000 years. I love you for 1,000 more. died every day waiting for you. Darling, don't be afraid. I've loved you for 1,000 years. I'll love you for 1,000 more. And all along I believed I'll find you, and time has brought your heart to me. I've loved you for 1,000 years. I'll love you for 1,000 more. One step closer. One step closer.
Oh, thinking about all our younger years. There was only you and me. We were young and wild and free. Now nothing can take you away from me. We've been down that road before, and that's over now. You keep me coming back for more.
And baby, you're all that I want. When you're lying here in my arms, I'm finding it hard to believe we're in heaven. And love is all that I need, and I found it there in your heart. It isn't too hard to see we're in heaven.
Oh, once in your life you find someone who will turn your world around, bring you up when you're feeling down. Now nothing can change what you mean to me. Oh, there's lots that I could say, but just hold me now, 'cause our love will light the way.
And baby, you're all that I want. When you're lying here in my arms, I'm finding it hard to believe we're in heaven. And love is all that I need, and I found it there in your heart. It isn't too hard to see we're in heaven. Yeah.
I've been waiting for so long for something to arrive, for love to come along.
Now our dreams are coming true, through the good times and the bad. Yeah, I'll be standing there by you. Oh. And baby, you're all that I want. When you're lying here in my arms, I'm finding it hard to believe we're in heaven.
Love is all that I need, and I found it there in your heart. It isn't too hard to see we're in heaven, heaven. Whoa.
Made a wrong turn once or twice, dug my way out, blood and fire, bad decisions, that's alright. Welcome to my silly life. Mistreated, misplaced, misunderstood, missing no way, it's all good. It didn't slow me down. Mistaken, always second guessing, underestimated. Look, I'm still around. Pretty, pretty please, don't you ever, ever feel like you're less than perfect. Pretty, pretty please, if you ever, ever feel like you're nothing, you are perfect to me. You're so mean when you talk about yourself. You're wrong. Seems the voices in your head make them like you instead. So complicated. Look how we all make it, filled with so much hatred. Such a tired game. It's enough, I've done all I can think of. Chased down all my demons, I've seen you do the same. Oh, pretty, pretty please, don't you ever, ever feel like you're less than perfect. Pretty, pretty please, if you ever, ever feel like you're nothing, you are perfect to me. You're perfect. You're perfect. You're perfect to me. Oh, you're perfect. Oh, pretty, pretty please, yeah. You're perfect. You're perfect. Oh, pretty, pretty please, don't you ever, ever feel like you're less than perfect. Pretty, pretty please, if you ever, ever feel like you're nothing, you are perfect to me. Aren't you something to admire? 'Cause you shine as something like a mirror, and I can't ever notice you reflect in this heart of mine. If you ever feel alone and the glare makes me hard to find, just know that I'm always parallel on the other side.
'Cause with your hand in my hand and a pocket full of snow, I can tell you there's no place we couldn't go. Just put your hand on the glass, I'll be trying to pull you through. You just gotta be strong.
'Cause I don't wanna lose you now. I'm looking right at the see truth somewhere in your eyes. Ooh, I can't ever change without you. You reflect me, I love that about you. And if I could, I would look at us all the time. Whoa.
'Cause with your hands in my hands and a pocket full of soul, I can tell you there's no place we couldn't go. Just put your hand in the glass, I'll be trying to pull you through. You just gotta be strong.
'Cause I don't wanna lose you now. I'm looking right at the other half of me. The vacancy that's out in my heart is a space and now you're home. Show me how to fight for now. And I'll tell you, baby, it was easy coming back into you once I figured it out. You're right here all along. Oh, it's like you're my mirror. My mirror staring back at me. I couldn't get any bigger with anyone else beside me. And now it's clear as this promise that we're making two reflections into one. 'Cause it's like you're my mirror. My mirror staring back at me, staring back at me.
Yesterday is history. Oh, whoa, whoa. And tomorrow's a mystery, mystery. Hey, I can see you looking back at me. Keep your eyes on me. Yeah, keep your eyes on me.
'Cause I don't wanna lose you now. I'm looking right at the other half of me. The vacancy that's out in my heart is a space and now you're home. Show me how to fight for now. And I'll tell you, baby, it was easy coming back into you once I figured it out. You're right here all along. Oh, it's like you're my mirror. My mirror staring back at me. I couldn't get any bigger with anyone else beside of me. And now it's clear as this promise that we're making two reflections into one. 'Cause it's like you're my mirror. My mirror staring back at me, staring back at me.
Show me how to fight for now. 'Cause I don't wanna lose it now.
It's like you're my mirror. I won't just survive. Oh, you will see me thrive. Can't write my story. I'm beyond the archetype. I won't just conform. No matter how you shake my core. 'Cause my roots, they run deep. Oh, you've so little faith. Don't doubt it, don't doubt it. Victory is in my veins. I know it, I know it. And I will not negotiate. I'll fight it, I'll fight it. I will transform. When the fire's at my feet again, and the vultures all start circling, they're whispering, you're out of time, but still I rise. This is no mistake, no accident. When you think wings. You know it, and you will not negotiate. Just fight it, and be transformed. 'Cause when the fire's at my feet again, and the vultures all start circling, then whispering, you're out of time, but still I rise. This is no mistake, no accident. When you think the final nail is in, think again. Don't be surprised, I will still rise. Whoa, and I still rise. Don't be surprised, I will still rise. Same bed, but it feels just a little bit bigger now. Our song on the radio, but it don't sound the same. When our friends talk about you, all it does is just tear me down. 'Cause my heart breaks a little when I hear your name. It all just sounds like oh, too young, too dumb to realize
that you should have bought me flowers and held my hand.
should've gave you all my hours when I had the chance.
Take me to every party, 'cause all I wanted to do was dance.
Now my baby's dancing, but she's dancing with another man.
Your pride, your ego, your needs, and your selfish ways cause a good, strong woman like me to look out your life. Now you'll never get to clean up the mess you made. Oh, and it haunts me every time I close my eyes. It all just sounds like
Oh, too young, too dumb to realize
that you should have bought me flowers and held my hand.
should've gave you all my hours when I had the chance.
And take me to every party, 'cause all I wanted to do was dance.
Now my baby's dancing, but she's dancing with another man. Although it hurts, I'll be the first to say that I was wrong.
Oh, I know it's probably much too late to try and apologize for your mistakes. So I just want you to know, I hope he buys me flowers. I hope he holds my hand, gives me all his hours when he has the chance.
Take you to every party, 'cause I remember how much you loved to dance.
Do all the things you should have done when you were my man. Do all the things you should have done when you were my man.
Do all the things I should have done when I was your man.
de retorno. Não, nada. Por enquanto, nada. Agora vocês devem estar a ouvir pelo computador. O som.
mandar o meu. Ei, teste. 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 Ele não está a ouvir assim. Teste. 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 Olha, experimenta agora.
Ei, já vos consigo ouvir.
Pois.
Olha, consigo-me ouvir a mim mesmo.
Ei.
Eu vou estimar. Não consigo outra vez.
Desculpa.
Consigo. Só consigo quando o vosso microfone está aberto. Um belo eco.
Ei. Teste. Está-nos a ouvir agora? Não. Está-nos a ouvir assim? Aquele que tu tinhas ativo. Esse. Está-nos a ouvir assim?
Sim, consigo ouvir.
Ok. E assim está a ouvir?
Sim, continuo a ouvir.
Consegue-me ouvir assim?
Sim, consigo ouvir.
E assim, consegue-me ouvir?
Consigo, sim. Consigo ouvir ainda? Certo? E depois tem que fazer mute, não é? Para não ficar o eco. Está bem. Eu também só falo no início e depois potencialmente para as questões. Pronto, então. Eu consigo ouvir o Gael lá ao fundo. Ok, então conseguem pôr aí os slides só para eu ver como é que eu vejo aqui deste lado? Certo. Queria só ver se vocês conseguem pôr aí os slides para eu ver como é que eu vejo os slides do lado de cá. Eu neste momento só estou a ver a landing page do Christopher Neto.
What I do is I bridge those communities together. So in the world of AV, I was asked by George a couple weeks ago, how do we present AV to an audio crowd? So I can talk about the trends, okay? And when I talk about the trends, I'm going to talk about the one thing that only one person has mentioned, which is AI. And in the world of AI, the only thing that concerns me in AI is not how something is going to be tuned by a machine or how something is going to be made processed, made easy by a machine. My focus is on speech intelligibility. And the reason why I'm going to bring that up and talk to you about that as a trend is a big portion of the work that we do at Midwich is provide gear and product to install around the world. A lot of products we sell are available globally. And one of the things that has happened in AV is that we have been kind of, in the corporate spaces, have been attacked and taken over by IT organizations. IT organizations are very simple. They like to take things off the shelf. If George made something that came off the shelf, guaranteed IT would love it. It has to be readily available, like your laptops that are dispersed and handed out by corporate manufacturers. So when you become a new employee, here's your laptop, here's your presentation stick, here is your cell phone. Everything is very processed. Nobody's talking about personalization. I think AI kind of does that. So why does this matter? In the world of AV, adjacent industries, as I point out on the slide, is what's impacting AV. What you're doing on the architectural side and the base building stuff comes back and reflects in the rooms. Because once the builders are out of the space, once the integrators have built the space, we're left with conference rooms that are not meant for video. We're left with conference rooms that have to be turned into audio conference rooms that are made of glass. Glass walls, glass ceilings, Italian marble table, and the best answer I got is you got a plush carpet. Welcome to acoustics and AV. That's pretty much it. We're not allowed to drill in tables. We're not allowed to put holes in walls. We can't cover anything. Curtains, books, anything to absorb sound, deflect sound is a no-no in the space, especially in a new space. So these are the challenges. And why I refer to it as wizardry is at one point, AV was left behind when all the trades left. And we were handed a box of stuff. And we were told, can you make it happen? In that box could be a blender, could have been a control system, a projector, and 3 microphones. And they want that to work for a 50-person conference room. Can you make it work? We were wizards. We had to get creative. We had to make things happen. And we were defined by the technology in our space at the time. So what has changed is that we have now products that have now helped us. AV, for many years, our products were considered ugly. It's an ugly LED wall. Now you find LED walls that when they're off, they're not black. They're made to look like wood or made to look like some sort of concrete or whatever you'd like. They will shut off and the image will come through it. Products like Absent is working on that. Products like Row are working on those things. We're getting better at getting not to be ugly. That's one of the things that when we talk about acoustics right now and any type of acoustic treatment, it's something that's coming out of the box, it gets slapped on the wall, and people are like, this isn't a recording studio, this is a conference room. What are we supposed to do? So products like the ones that Artnovion's working on are beautifully designed. They sound good, they look good, and they fit the part of what the designers, architects are now looking for. Again, you still have my ugly tech in the space. You have black microphones. We love black products. Black microphones, black control panels, black projectors. I worked for a company called Barco at one point. Barco worked out of Belgium, and we made very nice high-end projectors in the same way that some people make some very high-end speakers. And Barco made the mistake once of coloring a projector. They made it Ferrari red. They showed it in an Asian market, and they could not, under no circumstance, stop the requests for, can we get a red projector? And for them to make a SKU for a red projector was very, very difficult. So they said, no, we cannot do that. And anything going forward was very difficult to do as far as color, because now you have to change the whole product line and SKUs. So when I worked for there, they're known for their click share, which was a wireless button, right? A lot of conference rooms have it, no wires, no nothing. You press a button, you magically present. This was 10, 15 years ago when they came out with this, where wireless HDMI was not a known thing, or not something that people were thinking of. So I said, yeah, you know what, why don't we, for like the 5th anniversary, whatever anniversary it was, why don't we make some gold click share buttons? That's when the story of the red projector came out, and I was never again would I ever mention coloring something. But anyway, so the adjacent industries that are impacting AV is in the corporate space right now, return to office has been a major battle. Ever since the pandemic, things have changed dramatically. At least in the US, cities are still empty, right? People have been predicting, oh, it's gonna happen today, it's gonna happen tomorrow, but none of these presentations that I've attended, whether it's been at a Modern Work Summit or some other summit, nobody is actually digging into the lease implications that are involved with changing the way we work. So you got companies with a lot of open square footage, and they don't know what to do with it. So this is what's now started to ball in motion. Plus you put in the fact that when people got sent home during the pandemic, one thing happened that we've not been able to put the toothpaste back in the jar or in the tube, is that we turned on our cameras and never shut them off. Turning on your camera changed everything. It was, in the world of AV, I have been on record, on podcasts, on written articles, whatever you name it. The one thing I hate is good enough. For me, good enough is a statement that says we've settled. We can't go any further. We've done what we can. Just accept it and move on. Well, good enough came to a screeching halt when we turned our cameras on. Because what happened is, somebody went home with a laptop. The laptop was great for about 3 months. They wanted something better. Then they got a USB microphone or a USB camera, which had better processing, a little bit better glass. That only lasted so long. They did one interview with a magazine on video or did some sort of video cast. That was not good enough. Moved to another higher end, more broadcast-like camera with better glass, better chip, faster, speedier. Then their computer couldn't keep up. So then they have to update their computer. So now they're not using their camera on their computer. They got a better camera outside. It keeps evolving. Trend. Good thing was, hello? You got me? Check 1, 2. Good. I get to go back to my DJ days in college. Tell everybody to put their hands in the air and wave them like they just don't care. Sorry. Thank you, sir. Appreciate it. It's the world. It's the world of what we live in, right? Technology. Every once in a while, it gets a hiccup. It's okay. I'm okay with it. If it was a customer, and I have had to done that. Anybody see the movie Hurt Locker, where there was a person who had to go in and fix things and the bomb's about to go off? Well, that was me for 13 years. I lived that as an end user. Worked for the pharmaceutical industry as an on-site designer and support for 3 pharmaceutical companies. And I would walk into a room full with just the same amount of people. And they're like, fix it. Video call. I'm like, I got your audio call going. You're up and ready. Let me work on the video. Yeah, they didn't have patience for that. I was fired every week. And every week they would tell me to come back. It's fine. I'm okay with it. I got patience. So the adjacent industries, that is one of that's kind of driving this new renaissance of AV, where good enough is not good enough anymore. People have elevated and escalated their level of what is good. So how does this relate to what we're talking about here? Not necessarily critical listening rooms, studios, but what we do have is broadcast-like setups now in corporate environments. You're starting to see more what we have here, full-blown setups of production, video production happening. And they're always picking the wrong space, every single one. I worked for a pharmaceutical company. We had a 5-person UC, Unified Communication Specialty team. My job was to create rooms, specialize those rooms, get those rooms ready. At the time, I think they were using Polycom. They've all shifted now to either Zoom or Microsoft Teams, which, by the way, are the anchor of everything I'm going to talk about when it comes to the AI at some point. Their 5-person UC team has now disappeared into and become part of an IT organization. The people that I worked with have been moved over and now are part of a 38-man on-site production team that do nothing but do sound editing, video editing, camera work, production. They now have 6 studios. They tore apart 3 of my divisible training rooms and turned them into permanent studios. You'll start hearing conversations regarding XR studios. XR studios are the LED backgrounds that you see in the newscast rooms. I'm telling you today, Fortune 500s, Fortune 100s already have them. They are taking those environments and they're finally doing something that they said and promised many years ago, which is we're going to go to a video-first communication. And why is that? I have a 23-year-old son and a 20-year-old daughter. If I send them a text, they will not answer. If I call them, they will not answer. If I send them an Instagram, I get an instant 2-second conversation. If I send them a video message, I'm outside, somebody come help me, I'm stuck under the lawnmower, they will come. If I call them, they won't pick up. So understand that if you're going to be using the idea of, was it the lawnmower thing? Do I look like I don't cut my own lawn. I'm from Jersey, man, and you can't. You're not allowed to cut your own lawn. I still have 10 fingers and 10 toes. We're good. So what you have is a generation of workers that are entering the space that are now focused, video forward. That includes our audio piece to it. Crackling audio is not accepted. Bad video is not accepted unless it's designed that way. If you're going to create a reel for an Instagram or a TikTok or so on, it's accepted that it's not the highest quality of anything. But it's that 30 seconds that they got to capture the information. So now you have CEOs that are delivering a Monday morning video to an institution as opposed to, hey, this is our week last week, we need to do better, let's raise sales. Nobody's going to read that. It's a PDF, it's an email. Not that it's dead, that still has its purpose. Video captures their attention. HR recognizes that. So now you have companies that are looking for funding and how are you going to add more conference rooms, more production spaces in that. But now these new players are involved. HR gets involved because they want a better produced video. They don't have the budget, but now they're asking for it early on in the year, so HR is helping fund these things. We've had instances where recruitment is obviously a big part of that. Universities, they spend their money in very unique ways. Not just to update their conference rooms and to update their classrooms, but we go in and help university football teams with their recruitment because we're updating their spaces. Their players want to be able to engage, collaborate within the environment of their locker rooms and training centers. In 1997, I worked for the New York Giants football team as an intern. It was the greatest story ever. My college, horrible. I could tell you that I went to school at a state college. You guys wouldn't care. But I played for the, not that I played. Wow, that would be great. But the fact that I was with the New York Giants for 1 year got me more play going forward, conversations regarding what is it that I do. I had a camera on my shoulder. I got to play with the cameras. I got to videotape the players, listen to their strategy. Excellent. That technology has now gone to the next level because I've returned to the NFL since and watched their meeting and practice and training rooms. They are doing some highly collaborative stuff. They're experimenting with technology for editing, for adding camera angles where it was just a 2-camera shoot. All these things are leading, and now they're starting to talk about audio. Because those football helmets all have speakers and microphones inside. They're all listening to their coaches. So how are they doing that? So, all right, it's time that I get to the AI part, and let me explain why AI is important to people sitting in this room. Everything you hear about AI going forward is typically based around productivity. It makes my life easy, it makes my job quicker, it allows me to do tasks that I don't want to do or can't do or don't have time to do. All great, all wonderful applications. Get yourself a Copilot license, go play with it, it's awesome. Microsoft Copilot, I'm sorry. That was not a plug for Microsoft. But one of the things that I learned going to Redmond to sit with Microsoft and them telling me about where Copilot is going is they kept dancing around the fact that for Copilot to be good, you have to train it. You have to talk to it. It has to learn who you are. Because going forward, it will be able to, and as I explained to George yesterday at dinner, if George is sitting at the second seat on the left-hand side and it has been trained to hear him, it will transcribe him and will do translations. That is the first and foremost, everything that any business wants right now out of Copilot. So what does that mean? It means that speech intelligibility is king. The audio in that room has to be perfect, more so than video, because the video, it's all machine learning. The video is great. Camera can detect 100 faces in here, but it can't tell you who you are. It won't tell you that it's some person. It won't know your name, company, all that, but your voice leaves a stamp, and that's what it wants. So audio becomes super important in the AI world. If you're designing spaces that are based around critical listening and high-end the conversational stuff, it has to be part of that. Not necessarily studio environment, but the days of conference rooms made of all of glass, open spaces, which is a nightmare for me. I worked in a building that it was a double helix design building. finding a room was horrible. It didn't make conventional numbering, just didn't work. It was like room 101F, high versus low floor. It was all over the place. We had a floating conference room that spanned across 50 feet in the air. The only way to get underneath was to get a high-low, to drop a metal panel, 25-foot metal panel, to pull one cable. And we were using Dante at the time. So we had an RJ45 going back to the table because we were only allowed one hole in the Italian marble table. And then that had electrostatic glass, very nice. You want privacy, hit it. Great. Glass roof. The building was glass with solar capture above, so this natural light. Everybody thought this was wonderful. Until 2 o'clock in the afternoon, where you were completely either in the shadows, or at 9 o'clock in the morning, where you were completely blown out because the sun had no way to stop. They didn't like curtains, they didn't want treatments, they didn't want panels. So we were in a big fishbowl. So when people ask, you know, what are you doing at an audio conference, like an audio conference? Like, I'm trying to relive my scars. I have PTSD from that event because I know nothing about this. We called in acoustic specialists to come look at this, and the best I got out of the architect was, this room was never intended for video. I'm like, this room wasn't intended for humans. Within 10 minutes of being in there, your ears were ringing. And I felt nauseous because it was just so much echo going back and forth. I didn't even have the proper terms. I'm sure somebody's going to school me later what that was, but I felt nauseous. So the world of AV has to deal with everybody's weird requests, and we get them all the time. That's why they're called integrators. We have to integrate the sound, the audio, the acoustics, control, lighting is even part of that. Depending on what part of America you are, lighting can be a sensitive topic because it could be a union problem, or it's my problem, or it's, no matter what, it's still my problem with the union problem. But anyway, I live in New Jersey, so it's union is an issue. So with AI, the focus on audio is super important, and it's not something that is enough conversation being had about that. And the last thing I'm going to talk about is immersive experiences. At one point, immersive experiences were pretty much something that was relegated to a retail or amusement or theme park. I'm not going to say that a corporate lobby is a theme park, but at some point, they want immersive. And what immersive is driving emotion. You can't drive emotion without proper video and proper audio. So the immersive environments that are now pushing this new wave of video, or new wave of AV, is super important because it's about initiating an emotion and a feeling. AV is not necessarily a cold thing. When you sit in a movie theater and there's an explosion, there's a lot of things going off. There's a visual and there's an audio component. The first time I entered the Sphere in Las Vegas, I was like, oh my God, this is just gonna be another hokey kind of thing. And I left there and I'm like, why isn't the VIXA, who is the trade show organization, or the organization for all of AV, why are they not out here with like recruitment papers to sign up the next wave of young AV professionals? Because it's a great example of what we and our combined brethren, whether that is, when I say brethren, I mean stage folks who do stage audio, who do recording studios, who do residential. I treat them all as brethren because we're all after the same thing. We're all using technology to answer a bigger problem, and that's whatever the end user throws at us. So again, that's why we're wizards, because nobody else is going to do it. Tell your IT guy to go fix why they can't read from 20 feet back on a 55-inch screen. Yeah, that's science. That's what we're built on, right? Throw distance and sight lines, stuff like that. That's all stuff that we see on the drawings and CADs. So now that I put down my clicker, I don't even know what else I had on here. All right, so why does it matter? So these trends matter because it doesn't matter what you sell. It's not us. Somebody's asking you for a microphone. They're not asking you for a particular brand. Your job as an AV professional, and my job as an AV professional, is to guide you to that and help you select the right microphone and the right speaker. and stuff like that. Even as a distributor, we listen to what our integrators are doing because we have in-house engineers as well and services that kind of help guide people that are just looking for, I'll take whatever's available. And that was also a product of the pandemic. We were left to buy whatever was available. And that mentality is now sort of kind of changed. We have selection. Obviously, the outside influences, that's the thing that I brought into it. Microsoft is not an AV company, neither is Zoom. Be very clear about that. Their job is to create this Microsoft Teams and Zoom's thing. They need our gear to make it wow. Best example of that, if you work for a corporation and you ask for a monitor, you're gonna put a 24-inch monitor in front of you and a headset. They'll just give you whatever headset they got. Or you can tell them you need something that is a little wider. I need higher end graphics. I need a better laptop. I need a video card that doesn't crap out when I connect an HDMI cable to it and a USB-C at the same time. So all these outside influences, why? Because there are people right now sitting in their mom's basement creating video at 16 years old that are doing incredible work with a computer that they built and put together, coddled in pieces. Meanwhile, I have a very nice corporate issued laptop that I can't run more than 2 windows open at the same time. So it's reality. The outside influences are gonna push what AV can do. Opportunity to rethink, integration and design. We're back to being creative. Because we have product, because we have the ability to go out to the market and say, there's a product that does that. Whether it's a microphone that's not a microphone anymore because now you have beamforming microphones. Whether it's using speakers that at one point were classified, you know what, that's just for museums. All that's now changed and it's now entering the space. So, and to wrap it all up, this is the call. The call is to be getting back to being creative. The products are there, and everything that has led us to here has been on the positive. Integrating the audio and the video portion of it is what our integrators do really well. As a distributor, I'm happy to provide them with the gear, but it's more of a collaborative effort and working, obviously, to improve the audio because God knows we could use better audio all the time. But that would be it, man. That's my whole presentation. All right. Thank you.
Thank you very much. Thank you very much, Chris, for this very insightful presentation. We'll be having a round table in the next few minutes. We're just going to start to prepare it. And we're going to be asking Donato Marci and Peter D'Antonio and Pique Pendy to join us at stage for this next round table. So we'll prepare it up, set it up in a minute. Thank you.
Good, thank you. Fantastic. Good. It's amazing. Artnovion has a really simple mission in the few years from now. We are seeking more and more about technology, seeking more and more about performance. We care about how deep we can go solving acoustic problems, but with a great agenda, which is try to deliver that with the right stamp regarding the environmental rules. And this is why Artnovion has a main purpose, which is deliver the best technology with less resource. I do believe companies has a main role on that, and Artnovion wants to be there. It's not just a greenwash thing. We want it to be green.
Chris, Dr. Peter D'Antonio, Donato Marci, and Pique Pendy. A round of applause, please. So, in the morning's initial presentation, Dr. Peter D'Antonio was kind of cut off because we started beforehand the Q&A answers, question and answers period. So we are going to give him some some time just to finish their presentation properly now. Thanks.
Thank you. Good to see you all again. I think our basic message is that the people that we put together in our company have over 40 years of experience in designing every imaginable type of space. PK has a lot of business experience, and I let him tell you about his background a little bit. And what our message is, basically, after 40 years, we have, in our view, finally developed software that enables you to design your space before it's built, to have the confidence that you can design this space and not have to deal with the problems that building it incorrectly may have introduced. And we can do that in very complex spaces, and in very complex spaces that are not just simply rectangular rooms. We can do that with our Nero and Tora software. That is a design service that we offer to the design team. It's an optimization service. And then before I go into that, let me have PK give you his background to give you some idea of the talent that we've brought into this group.
My background is from the AV space. So I started in 1995 at Guitar Center, and then in 99 I founded GC Pro, which is a business-to-business service that we offered. And we did that for 20 years and built it to about 100 million subunit of Guitar Center, which is a $2 billion company. And throughout my career there, and still to this day, because I still am an integrator, and I have a company, Avian Systems, that does all this, you go into lots of different rooms, and you're selling studio monitors, speakers, things like this, and the room, you're always fighting the room, no matter what. The speakers will never win, and your client is disappointed with the speakers. It's not the speaker's fault. You need to invest in your room first, and then any speaker will sound great in there. So having a passion for acoustics and knowing Peter for a couple of decades, and John Storick for 4 decades, we now have a way to predictively design your room so you can listen to any speaker that you want. So it's just that passion to really have a great room.
To reinforce what PK just said, we have those optimization tools, but now we have a user-based tool. ROX is the room optimizer for keyboard spaces, which you can go in. It's an app. It's on our website. PK's making it available internationally. And then we have the acoustical treatment calculator, where you can actually calculate the acoustical products. If you want to buy acoustical products, you can do that. And of course, you know, have 40 years of innovating acoustical products at RPG. George has a lot of experience over his 10 years in creating a nice library of acoustical products. But the idea of the ROX is to you put your length, width, and height in, and Arthur is going to give a demonstration. The reason we didn't go into the demonstration during the presentation is that it's kind of a complicated, demonstration, where you put in all your known quantities, your length, width, and the height, the speaker height, and then you indicate which you can vary. Like if your ceiling height is fixed, then you can't. That's not a variable. And you choose from a library of, I don't know, maybe 100 speakers, which speaker you're going to use in the room. And you can actually audition the speaker in your room before you buy the speaker. Okay? And so that's kind of a summary where we've given end users these tools as an online app. And then we have this more complicated optimization service for more complicated spaces. And, having worked with WSDG for 40 years, we've been involved in almost every one of their projects. So there's just a large body of experience that we've brought into Ready Acoustics. And then we have, to keep the ball rolling, we have 4 very talented programmers and acoustical engineers to keep it current, to evaluate the importance of AI. We are still coding all of our software, primarily in Python, but we can use AI as a guidance. We can use it to, we have this particular issue, so AI is good at proposing a software solution. But then you have to integrate it into your software. The beauty of our software is that we deal with every aspect of the experience, the room, the positions of the speakers, the positions of the listeners, and the positions of the acoustical treatment. You know, Bruno had a nice description of where you place your low frequency absorbers, where you place your porous absorbers. You want to place your porous absorbers at high particle velocity. You want to place your low frequency absorbers at high pressures. The most ideal position for a low frequency absorber is in the trihedral corner, because every mode in the room is located there. The second ideal solution is the dihedral corner, the two wall interfaces, you know, and so you don't want to, you may not have the opportunity to address those spaces. That's the beauty of the predictive software. You might only have the ability to put a low frequency absorber on a wall at a certain location. Well, the software will tell you how effective that could be. It's not going to be as effective as placing it in a trihedral or dihedral corner. So if the other gentlemen don't have anything else to contribute,
Thank you, sir.
we can take
Thank
questions.
you very much. Yes.
Yeah.
Well, we've prepared a QR code, so if you want to, you can scan this QR code and submit your questions, and we'll be happy to address them in the order they come. So you can start. Maybe I will start with a question of my own before we have. Oh, do we have? Oh, we have an anonymous question. What's the future for active bass traps? So who wants to take this one?
I mean, they're a tool. It's just like there's a lot of tools to use. An active bass trap is a device that determines wherever its location is. It'll determine like what problem in that, what is the frequency in that particular area that can be treated. And that's okay as a retrofit. We are dealing with solving the problem from the beginning, okay? And so there's a place for that, just like there's a place for all of the acoustical treatments.
You have to know where to put the active bass trap.
And you have to know
That's
where to put
most important. The second question we can
Yeah.
answer. When you say you can hear your speakers in the room before you buy it, does that include high-end audio products as Tidal loudspeakers or Magico, Wilson, etc.? Absolutely. We just completed Tom Martin's room for the Absolute Sound, his room in Texas, and he has Magicos, and we've done a couple other rooms with Magico and with Wilson speakers specifically. So yes, we have those models. If they're not in our library, we will model them and put them there.
So
Yeah, I mean, so we've dealt with the leaders in recording studios, certainly. We've dealt with the highest of end studios. And with Tom Martin, who's the editor of Audiophile magazine, we've dealt with audiophile rooms. We've dealt with home theater rooms. So,
yeah. So this is a general question as well. So which, and this is being asked by someone in the audience as well, which emerging technologies do you think will be most disruptive in terms of acoustic engineering over the next decade? What's your bet?
you guys
I
want
will try. Of course, knowing the future is not easy, but I believe that using the AI or this kind of machine learning can be very, very useful in order to calibrate the models. Because, of course, we have the technology to do simulation of low frequency in small rooms, or maybe ray tracing for bigger rooms. I will talk in the next in my talk later. But the focus, in my opinion, is, as D'Antonio says, is knowing the impedance to tune the model for the small rooms, and know the absorption for example, in very complex environments, such as cathedral, for example, for larger rooms. In order to do this, we have to find a way to match with some measurement, for example, to understand this kind of physical values, physical parameters and put in our equation, in our solvers. And that's where the AI can help a lot, in my opinion, for the future. So that could be the Saint Grail of the future of the acoustic, in my opinion. Because we have the tools, but we cannot use so well because we need the parameters to put on to the values, and AI can help us.
Christopher, would you say that in terms of speech intelligibility, this would be like if you had your own R&D team for the audio, for sound, just for sound purposes, would you go for that?
Yeah, and the reason why is this thing? Oh, there it goes. The reason why speech intelligibility is such an important key, obviously, because it's tied back to how AI is going to read. The feature set of AI, how it's proposed to the corporate user, is that it's all about translation, and it's all about translation services, and it needs to hear the differences in how a person speaks. It also is doing transcription. So to have a meeting, to rely on a meeting and its AI to transcribe everything is super, super important. And to be honest with you, I would say half of the people that are currently possibly even investigating that Copilot integration into their Outlooks and Outlook teams are looking for that assistant, which is now listening to them, talking to them. It needs to identify them, and it needs to understand that, you know, I'm from New Jersey, I hold back my accent. Somebody from, you know, a Southie from Boston has a very thick accent. You go south to the US, you know, even within Portugal, we were discussing this yesterday, within Portugal, there's stocks within how they speak. Some people speak 100 miles an hour. That all has to be processed, and that also all has to come very clear into the microphones. So to me, it's not just the power of the microphone and the ability to say, yes, there's a microphone close to my mouth, but trapping all that sound and keeping that away and out, because there's a lot of magic out there. There's a lot of things that companies are doing that, or they'll call it like misting, where they can block out sound behind you but just keep the sound in front using some sort of beamforming microphones and stuff like that. That's their special sauce. How they do that, that's their business. But that kind of stuff is what's coming to us now. So that to me just seems to be a constant emerging stuff. The video stuff, cameras are cameras, chipsets are chipsets. Every chip is getting bigger, faster, stronger, faster. Glass is getting better. Audio is the one that I think is the bigger key. So.
Great. To add to that, if I may, the most important thing with respect to speech intelligibility is the acoustics of the space. Speech intelligibility goes totally downhill when the reverberation time is too large. Speech intelligibility goes downhill when you have interfering reflections in the room causing comb filtering. So, as PK mentioned, people have relied on, they'll come and say, well, my speakers aren't doing the job. That's not the solution. You know, the speakers that are designed today are so incredibly good at reproducing sound. It's what they're doing in the room. Where do you place them? Where do you sit to hear it? It's all about the interaction between the sound and the room.
Yeah, we have a question from Bruno Frazenda, actually, who has posted this question for Reddy. Have you considered incorporating the behavior of active bass control systems like PSI or Trenov in your predictions?
Well, we did a room that Tom Martin had a couple of PSIs, and they weren't working. The results were so much better when you designed the specific treatment to deal with whatever he was doing. He's just guessing with that, and guessing and measuring. Yes, you know, putting in measuring and lots of putting a responsibility on the client there to really tune their own room. And Trenov is, we sell Trenov as an active DSP solution that goes at the very end of your chain before it hits your power amplifier or hits the speaker. And that's just a DSP like any other DSP. So, but we don't really take that into account when we're doing any of our predictions. But we do know from our work is that you will need less from the Trenov or any other DSP when you're doing your final adjustments and tuning on the room to your taste, because that's what it's designed for.
First of all, hello, Bruno. I wish you were here.
He is, yeah.
and I remember back when I was working with Trevor Cox, when these active treatments were being developed in corners, and you couldn't get enough power to control the mode, and so they've come a long way, but they're a tool. And when we finish our design, our goal is to make the room neutral. In other words, we want to erase the acoustical signature of the room. But then, after we do that, our clients basically go in and then they tune the room. You hear about room tuning. They tune the room to what they want the room to sound like. That's not our responsibility as an acoustical consultant. Our room is to make the room go away. And then they have their own impression of what the room should sound like. That's after we're finished. We're giving them a clean slate for them to paint whatever picture they want to paint. So active acoustics is just another tool, but it's a tool to fix a problem that doesn't need to have to be there.
But do you think there will ever come a time where active solutions in a standalone will be able to fix or to bypass design or
Never.
passive? Okay.
Never, because active solutions are intended to solve the problem at one place in the room. You move your head 1 foot and you have a different response.
Yeah.
So our goal is to create a uniform listening environment. And an active treatment is no better than a passive treatment. At least that's our opinion.
Okay. Donato, do you want to take standards also about this neutrality and the approach with Dolby?
Okay. You asked me in their intervention. They talk about neutrality for the frequency response in rooms. Yeah. Or not. I believe that our work as acoustician for studios is 50% science, 50% art. And so, of course, from what I can say is that I like flat frequency response for rooms. But I know that a lot of clients prefer a different kind of frequency response, in particular for low frequency. And I have to tell a story. When we became Dolby Certified Service Partner in 2021, because the Dolby Music Program, Dolby Atmos Music Program starts, we just design a lot of studios for home entertainment and for theatrical, but it was the time where the Dolby Atmos came to the music industry. Everything this question was really tricky, because Dolby asked us to do final calibration for the rooms and to calibrate using a mask, using a tolerance on the low frequency and the mid-high frequency. And the curve is not flat, because Dolby came from the X curve from the cinema industry. And that's a fact, because that's the curve that is an ISO standard that you can better match a far field listening of a speaker behind the screen. And so this is a fact. But when you move in a room without a screen, with a speaker at 1.5 meters, it's totally different. So I can say that this thing will be start in the USA. When came in Europe, a lot of sound engineers from UK didn't want to adapt to this fact and want a flat response in the mid-high frequency. They are okay with the low frequency, a little boost in the low frequency, but they don't tolerate a knee in the frequency response in the mid-high. So Dolby told us to be more, it's something that we have to choose with the client at the end. And so in general, when we do Dolby calibration at the end, we can do different setup also to match in different ways. from what I can see, the people that works in EDM or electronic music want a little bit boost on the low frequency, and maybe a smooth decay on the mid-high frequency. But if you talk to classical musicians or jazz or something, they prefer flat responses. So
we see that. We've done a lot of Dolby rooms.
Yeah.
We do the whole Dolby Dart array system. We also use, even for non-Dolby, we use a subwoofer array.
Yeah.
That we put in the ceilings and some other locations to equalize the pressure. And we've also found that in Dolby creation rooms, like the studios, they're the ones who want a more flat response because they're in the creation and it has to be played back where, in whatever cinema, headphones, wherever it may be. And in the theaters, the home theaters, commercial theaters, they want the extra. They want the low frequency effects to really pop through.
I mean, that is the big difference. If you're in a room where you are creating the musical content, right? You want to know what you're hearing. It's not a preference at that point, because if you tailor the room to your preference, and I'm not saying don't do that, but when you take that mix out of the room, you're hearing something totally different.
Yeah.
You know, Dolby's background is making it feel good, right? That's why a home theater, you're not too concerned about the acoustic aspect of it. You just want to feel good. And so you have a nice surround sound. But in the creation process, it's a very different situation. And it's really hard to get that point across. You really have to be in a room that is not contributing to what you're hearing.
Yeah. And going back to the DSP, in the creation rooms, they can have a preset set for that.
Exactly,
for the playback vibe, you know. Right.
You could listen to it flat, and then you could listen to it with whatever emphasis you want to put on it.
Yeah.
Okay, so moving on to another question. The problem of many modern rooms having lots of glass. And what solutions or tricks to solve this problem and the challenges that come with glass walls would you advise?
So many
not breaking the glass, except, yeah.
So many years ago, glass is a major problem. And I remember talking with John Sturek a while ago about, you know, because in control rooms, you often have glass walls. And so what we did was to do a micro-perforated foil. It's a very thin mylar foil with micro-perforations. And it's very absorptive. When you have a cavity behind it, you could use a double layer foil for broader band absorption. And then we also created a perforated acrylic panel in which you can get both absorption from the panel, depending upon your air cavity, to determine how low in frequency you can go. Yeah.
So just, yeah, could you place that question or over, if you want a microphone, we can hand you a microphone.
So to control glass, you have two options. You can angle the panel to control the direction that the reflection is coming, but you have to realize that the only thing that you could control in the frequency of that reflection depends upon the size. You know, once your wavelength gets to be comparable to the size of the wall, then you're getting a diffuse sound coming back. So just by tilting a panel, you have to realize that you're not controlling all of the frequencies. You're only controlling the frequencies that are specular with respect to that surface that you're reflecting. And then you can introduce perforations to provide absorption. So you have reflection control plus absorption.
What about metamaterials? Would that be able to help?
Metamaterials, I worked on metamaterials for about 4 or 5 years, and the metamaterials have an application, as very well described. When you see a lot of the applications, they're above 125 hertz. Once you get down to low frequencies, it's kind of difficult to control that with metamaterials. I have tried, believe me. The theory is there, but when you go to make the panels, they're very difficult to manufacture because the porosity is, the diameter is very, very small. And I think they have a future, but it's going to take a lot more developmental time.
Any material you consider has some potential?
Any new material?
Yep.
Not really. I say the newest material is microperforations. We introduced microperforations to a company in Switzerland many years ago, Top Acoustics. And now microperforated materials are essentially becoming the favored architectural solution because you don't see the acoustics. It's a panel. It looks like every other panel in the room, but the microperforations provide the absorption that is required. And we make all kinds of microperforated panels, all forms of perforated panels. Some of our low-frequency absorbers, like for the mid-frequencies, are perforated panels, Helmholtz panels. And when you get down to lower frequencies, we decided to go into these membrane approaches that Bruno described very, very well. And so in terms of new materials, the microperforated foil and acrylic, the membranes, the tunable low-frequency membranes, we go down to like 37 hertz. Those are kind of the new materials that are affecting architectural acoustics.
Okay. We have a question from Professor Rui Calejo to Peter D'Antonio. Do you want to read that one? Why do you use finite elements modeling only until 200 hertz and not in all frequencies? Ray tracing and ISM give better results.
Schroeder frequency.
Yeah, so there's a frequency in. If you look at the frequency response of a room, you have the pressure zone, and then you have the first mode, and then. So the modes are individually spaced, and the problem with modes, not so much that they're a problem, it's just that they're spaced in time, so you hear them, they're audible. And then as you get to a certain frequency, thanks to Manfred Schroeder, who's invented everything else in our field, you get to the Schroeder frequency or the transition frequency to the point where the modes are no longer spaced in time, they almost superimpose on each other. And so as you get above the Schroeder frequency, you get more of a modal uniform distribution. Yes? Yeah.
Sure. Yeah. Please use the microphone, yeah.
Hello, hi. So one of the issues with this method is that it depends on the mesh, because for higher frequencies you have a shorter wavelengths, and then you have to have a mesh that is a lot finer.
Do you want to join us on stage?
No, I think it's okay.
Because of feedback, yeah.
Of course. Let me get here.
Well,
okay.
Speaking. Yeah.
So the mesh has to be a lot more finer, so you have a lot more points for the computer to compute. And it gets to a point where simply the computer cannot compute anymore because it doesn't have enough RAM, and it would take so long that would become unfeasible to many applications. So this is one of the main issues with high frequencies with those methods. It's just virtually impossible to compute them with normal computers in a time that is accessible for most applications.
Yeah, quantum computers will make a change. Yeah.
Hope so, yeah.
Yeah, now that is really a new thing, right? The reason we can do what we're doing, the reason we can look at thousands of possibilities is because of computational power. Yep. And to use the cloud. Yeah. So between the cloud resources and the software that we have, that has become almost another acoustical tool. I mean, it's a very powerful tool. It allows us to do all the predictions beforehand.
Yeah, okay. Sir, do you want to please? Oh, yeah.
Hi, I'm Morten from Tonax in Denmark, and I'll just say a little bit more about the glass.
Oh, yeah.
We have invented the acoustic glass now. You can use your normal glass, put it together in a new way. Okay. And together with the acoustic from Artnovion, you can make a good room. Yeah. So it is actually possible now to make as bad as glass is, as good as you can make it now. But it's new, I can present it afterward, if anyone want to know. But it's a basic, that you need a good speechability, and that's what we need of the acoustic material. Everyone. And another, if I can, we are coming from a department of people that are bad hearing. What we don't acknowledge is that we are close to 20% of the population in the workspace. They actually have hearing problem. So 20% of the population we can help with the acoustic.
Yes.
And that's very important.
It's a very good point.
Yeah. And yeah, statement.
Thank you. Thank you. Thank you. Chris, would you have anything to add on this topic? Because is this something that like big companies are looking at in terms of hearing impairment and
Yeah, last I checked, our hearing doesn't get better with age.
No.
So it's obviously an issue. Yes, assisted listening is another, I guess, another vertical within AV that is super important at this time. You got companies that are basically, that's all they do is assist into that to help people with assisted listening, which at one point was just relegated to special events and auditoriums. You're now seeing that in other type of spaces. So yeah, it's a growing field. It's a concern. There is obviously there's a need for that, and then people are being more concise about that. As you walk into spaces, do you need that? And some are going into just regular Bluetooth type stuff with the hearing impairment, and it's helping. But yes, that is definitely on target. But as far as class goes, man, I still have a lot of bad memories from that one room. I think I wake up in cold sweats thinking, okay, thank you, appreciate it.
And there are methods to determine speech intelligibility. We've worked on that for ages. And so, you wonder, you go into a train station, why can't you understand what stop to get off? You go into so many areas, and the acoustical aspect is what determines the speech intelligibility, as long as the auditory hearing.
But can you fix a drive-through speaker thing? I can understand that.
Well, that's where we have the integration.
That's where we end. All right.
Okay, we're heading for our final minutes. We're just changing the topic for the problem of architects not knowing or not being willing to incorporate acoustic technologies or solutions. So what's your advice on how to deal with that? Yeah.
We deal with them every day. Almost every one of our projects has an architect or an acoustical architect involved. And it's just having meetings with them and having them incorporate the treatments into their design. I think it's just spending time with them.
Yeah, from an integration standpoint, that's the architect will design the space. An acoustician will come in and design the audio for the spaces. Then the end user moves in and everything changes. Yeah. That's the hardest part, and that's the part that we can't control on our end. Technology doesn't solve everything. We do a lot of cool stuff. We add wow factor to a lot of cool things. But the fact is that until when all the trades leave and we're left behind like I was for 13 years, then that's where the ask happens. And that really starts not with the architect, but in the design plan of that building, there needs to be more end user questions asked. What is your intent? What is your purpose? Because a video conference room is not a presentation room. It's not a huddle room. And there's 1,000 different names for whatever room you want to create. And you can create a 3-person conference room. Then it was intended with no technology. And that could be glass. But, what happens when they bring something in there? And then, unfortunately, because of where we sit on the food chain, and that's commercial audio video, we quickly get that term called value engineering thrown at us. And for many years, early on, when I was in my career, audio conferencing systems were eliminated in place of a starfish phone in the front of the room. And that worked. It was, I hate to say it, but it was good enough. It's now needs to be integrated into the whole space, into the room. And I think that's where there is a mindset that needs to change. And going back to the architect and stuff, the architect and the acousticians are there day one, that's awesome. But when they leave, then it turns into the Wild West. And that's where the on-site engineer really needs to, or the on-site people that are left behind that work for the companies, have to be better trained, better adapt to asking the questions ahead of time and meeting with these folks early on in the process, because that's the biggest fault that AV has, is where we fall into the process. And we're usually the last ones coming in. That's where they're usually the last trade to leave, unfortunately.
I mean, that's the issue. Design is a compromise. We talk about it in terms of the 3 A's. You have the architecture. You have to know what is accessible architecturally. You have the acoustics. What is accessible acoustically? Where can you place things? And then you have the aesthetics. What does the room have to look like? That's why I spent so much of my career designing products that are not visibly acoustic. You know, an architect doesn't want to see an acoustical product. He wants to design the acoustical product. That's why we developed this software where you can put in the topology that the architect wants to see. The acoustician can look at the results from our calculation, and he has information to go back to the architect and say, I know you want to see this surface, but and we'll try to do it, but you have to realize that we're not going to meet our objective if we utilize that surface. So it's a compromise.
Mm-hmm. Okay, so I think we have time for one only last question, and we have a suggestion here for each speaker to point out the technological advancement or problem to be solved that you are most excited for witnessing in the next 12 to 24 months. And we would finish with this longing.
Mine's not going to be audio. Audio's easy. Mine is going to be more on the transport and standardization. In the world of AV, standards is a hard thing for us to get our heads around. And I'm currently watching a war brewing amongst how signal is transporting. And the reason why I say that is because 2 weeks ago I was in Amsterdam at IBC, and IBC is a broadcast focus show. And then I go to an AV focus show, and when I hear the miles apart they are as far as transporting video and audio and everything, we're trying to cram a lot of stuff into a pipe, right? It's the 10-pound turkey in a 5-pound bag, and we're trying to get it down from A to B in one piece. And then the two worlds that I play in, which is the broadcast side and the audiovisual side. The broadcast side wants uncompressed raw sent to one side. AV wants to compress it and send the most efficiently because they're sharing a network. That will be an internal battle for the next 18 to 24 months, is how we're sharing it. Now, everybody can go in and talk about VPNs, and I can go down an IT conversation that I don't want to have. But it's an interesting one in that there are different standards and different groups within that and how they send that transport. That's obviously, for me, it's important to watch because I see a connection between broadcast and IT and AV all starting to come, and it's becoming more apparent now than it was 3 years ago when I went to my first NAB. And watching this kind of go, you're listening to AV integration companies start to talk about Adobe and edit, share, and processing and how editing, and it's very different. They're just not talking about audio, video, lighting, and control, which was our basis foundation for many years. So there's something new coming, and that's my feeling.
Okay, Donato.
I don't know, in the acoustic field, of course, the audio industry is faster than than the acoustic, probably. I totally agree with D'Antonio about the micro-perforated foil, and I think that it can be used not only in indoor acoustics, but also outdoor. For example, let's think about using porous material for barriers in highways. They get wet, and we can use, in this case, micro-perforated steel in order to make it more efficient and life longer than the others. Exactly. And of course, about the active absorption. We had an experience in the past. I can see that active absorption can be something interesting, but at the end it can be used like the passive one. So in general, the price is very high. So if you have to balance this now, it's not so effective in my opinion. But it works quite well in the very low frequencies. And now, if the idea is, okay, using active absorption on the very low and maybe porous material, the crossover frequency is not enough now because it lacks between 100 to 200 hertz and is a very important part of the spectrum. Yeah. So, I don't know.
Metamaterials. I actually want to see one in real life that works, that we can use. Okay. That's all I want. We've been studying it. I'd love to see something come to fruition that we can use for many different applications.
Very simply, more computing power. We know how to program. We know what we're doing. We just need more computing power.
We need a meeting with NVIDIA.
Okay. Okay, so thank you so much for this very, very inspiring moment. A round of applause. And we will now break for lunch. Okay, please enjoy the rest of the time to mingle and to network and enjoy your lunch. Thank you so much.
Thank you.
d'Azur et Saint-Tropez. Tour de France, Tour de France. Les Alpes et les Pyrénées. Tour de France, Tour de France. Dernière étape, Champs-Élysées. Tour de France, Tour de France. Jusqu'au sommet, Tour de France, Tour de France. Pédaler en grand braquet, Tour de France, Tour de France. Sprint final à l'arrivée, Tour de France, Tour de France. d'Azur et Saint-Tropez, Tour de France, les Alpes et les Pyrénées, Tour de France, dernière étape Champs-Élysées, Tour de France, Galibier et Tourmalet, Tour de France, on danse jusqu'au sommet, Tour de France, pédaler en grand braquet, Tour de France, sprint final à l'arrivée, Tour de France, crevaison sur les pavés, Tour de France, le vélo vite réparé, Tour de France, le peloton est regroupé, Tour de France, camarades et amitié, Tour de France,
don't fuck with you. Shall I go? Or shall I come? Live from Badubotron, Nubian phenomenon. On and on, and Mama's gone. Underwater eel motherfucker, put on the other side. 214, all in my phone. We from Dallas, baby. Freak, freak zone. Freak, freak zone.
Um indivíduo é outra vez. 1, 2, 3, não faz feedback. Não apitou, não pagou.
Alô, alô, alô. Estou a mexer, estou a ir ali para o local do crime. Ficar aqui.
Sound brings deepness to things and meaning to life. Sound is everywhere. Inspiring us, challenging us, lifting us. It's just there, everywhere we go. We just need to choose to walk with it. And to those with the opportunity to touch people's lives, there is a greater mission: to push the barriers of science, to design beyond your imagination, to build timeless foundations, and to lead the way for pure sound. May a new generation of sound sculptors arise and dare to live the heartbeat of sound. Will you join us?
Will take us on a journey to Abu Dhabi. So a place where bold ideas meet unique challenges. So please welcome Jonathan Kino. Thank you.
That's the worst video to go on afterwards if you have a New Zealand accent like I do, because I sound nothing like that guy. And if anyone has like an AI translator to help you understand my English, you probably need to use it now. I'll try and speak slowly and clearly, but forgive me if it makes no sense. Just smile and nod. So, this also looks like the wrong presentation, but I think it's okay. I think we can do it. Look, this has been a fascinating conversation. I'm not an audio engineer. I'm not an engineer. I'm not an architect. But I've been in Abu Dhabi for the last 15 years and working across any number of projects, a lot of architectural projects. And it's interesting how few of those conversations and projects have talked about acoustics and sound engineering. And so I think what I'm going to try and present today, and I'll try and do it quite quickly because I know we're a little bit behind time, but I think the key word of what I'm going to speak about is the word identity, and how these conversations of sound and acoustics and frequencies and bass and passive and whatever the opposite of passive was that I can't remember, how they actually translate to a place like Abu Dhabi, because it needs to have those conversations, and in a lot of the projects it's not. A little bit about us. I'll stand not in front of the screen. This is us, Slash. We are a multidisciplinary design studio. We work in design, architecture, events, exhibitions. We do a whole lot of different stuff. In Abu Dhabi, we have a full production facility of making things and items and products. We have a concept store. We have a team of about 85 different people across about 25 different nationalities, which is very much like a good snapshot of Abu Dhabi. I also just realized my presenter notes aren't on here, which I'll do my best to remember what they were, but if you can find them and make them appear on that screen, that would be good. Anyway, that's us. We've been in Abu Dhabi for 15 years. In the UAE, for 15 years. First Dubai and then Abu Dhabi. Like I said, working across a whole lot of different projects. We've done private jet companies, branding in the interior of aircraft. We've done commercial spaces. We've done lots of different cultural spaces. Just a quick show of hands, who's been through Abu Dhabi or Dubai before? Okay. And probably most of you have seen stuff online or on the news about the place. We've done the branding of palaces and of private event spaces. And I think to the question that I just asked, who's been through, I think the reason I asked that is because this is the picture most people get of the UAE, which is kind of true, unfortunately. There's a lot of shiny gold stuff. There's sometimes camels crossing in front of the sunset, not very often. There's a lot of this. A lot of these massive echoey rooms made of marble and plated in gold, that's kind of common. But that's not all there is to the UAE. That's definitely not the majority of the UAE, and that's not the kind of projects that we work on. And that's why, hopefully what I'll bring to you today, a little bit about the idea of identity, makes a little bit more sense when you start to think of Abu Dhabi or the UAE as an emerging market and somewhere where these conversations need to start happening. Because this, I'm being really careful. I got told to only push the down on this thing, so I'm like really careful not to stop the presentation. This is the UAE that we know. This is the UAE that takes a lot more time to get to know, but it's very, can be very natural, very grounded. It can be very authentic. It involves a lot of amazing, massive, mega structures and whole cities that have been built, but it also involves beautiful sunsets and hanging out on boats going pearl diving. Interesting, this picture in the middle here, this was a project a couple of years ago that we did for a week. We had 40 international consultants, so some of the best architecture firms, sustainability experts, mobility experts, urban planners, designers, that came to Abu Dhabi for a project, and the client said to us, we want you to bring these guys in and give them an Abu Dhabi experience, because they're going to build something for Abu Dhabi, and it can't be done by a Google search. Their research can't be just looking online and trying to understand what Abu Dhabi is. So this is a photograph we took underneath the mountain, the one mountain that Abu Dhabi has. We were talking about the geology of Abu Dhabi, and this was a site that they will be building on in the future. And it was really interesting to have the client say to us, we want these people to come and forget what they know from Norway or from America or from Canada or from Australia, and understand what Abu Dhabi looks like, what the people are like, what the food tastes like, what it sounds like. When you're standing in the empty quarter in the middle of the desert and the sun's just come up and there's like a single falcon kind of cruising across a skyline and you just have an ocean of desert, how does that inform the identity of what you're going to build? Because you can't have a copy-paste of another building from somewhere else. A little bit of context for Abu Dhabi. I'm going to say the word Abu Dhabi or the words Abu Dhabi a lot, so just it'll get baked into your head. You probably can't see the bottom there, but 1950-ish, the population of Abu Dhabi was 4,000 people. So it was a fishing village. It was tiny, and literally a fishing village. There was nothing there. 2023, when I created this slide, it was 1.5 million just in the city of Abu Dhabi. It's about 4 million in the Emirates, the larger, like the state of Abu Dhabi. So you can see in 50 years, the change has been like phenomenal. The development is insane. And this is an incredibly simplified version of that change, but this is kind of what Abu Dhabi has passed through. It's had the period of building cities where they literally had nothing. So it was like, we need roads, we need schools, hospitals, we need water, we need power, we need electricity. Didn't have it, had to build it. That was the 1950s, 1960s. Then, oh, what's these weird symbols? That's odd. Okay, we'll call it a design feature, these little things here. We had this really beautiful period in kind of the 70s, 80s of late modernism, where we had these buildings that focused on like shade and this ideas of like really practical, functional buildings. And then we had this other period just after that, which was a period of excess, where there was a lot of money, and you guys know how much money gets thrown around there, where we didn't need to worry about shade and about practicality because we could afford to do what we wanted. So glass and marble and these crazy big spaces became a thing because we didn't have to worry about building practically. And then we've entered this really interesting period recently, which is about understanding identity. And this is where, if you've ever seen places like Saadiyat Island, where the Louvre, Abrahamic family house, the Guggenheim, where those projects are being built, it's very much focused on this question of, well, what does Emirati architecture actually look like? Like, what is a design from Abu Dhabi? Because it's not a copy-paste of somewhere else. And it's really interesting to hear these conversations today and think about, well, what does Abu Dhabi sound like? Because it doesn't sound like America, doesn't sound like Europe. When they sing songs, even the music is not the same. The spaces are crazy, they're big, they're grand, but the sound is not the same, and we don't have an identity for that. And a lot of the projects we work on, 99% of the projects we work on, are to help answer that question. What's the identity of Abu Dhabi? And it's a tricky question because there's no answer to it, or there's no answer yet. But everyone comes in with their idea of what it should be, and then we have to try and bridge international expertise with local knowledge. And it's very much this conversation. the past and the future. So this idea of this really rich heritage, culture, and identity, 10% of the population is Emirati, 90% are expats like myself, so which is a massive imbalance. But there is a heritage, there's a way they used to do things, there's a way that society works that they want to hold on to, but at the same time, they're fully intent on stepping into the future and saying like, no, like, AI is a thing that we want to lead in. They know that one day oil will run out and that won't be a thing anymore, and so they're setting themselves up for what the future looks like. We had yesterday or the day before Sam Altman, the whatever CEO dude of OpenAI, he was in town opening a university there, and so we have those AI sustainability conversations happening constantly, but always with this as well, because they don't want to go so far into the future that they forget this, but they also don't want to stay here and not be able to go there. And they have the resources to do this, but not a lot of knowledge in how to get there and how to go where they want to go. A lot of our conversations center around this as well. The past was very much about designing places. So like I said before, there was nothing. So you had to design a place. We need apartments. We have like 10,000 people moving to the city next week. Design some apartments. And they just throw apartments up, and they're not beautiful. They're not amazing. They're just blocks that people have to live in. They designed a lot of places for 1.5 million people. And the conversation now is about this, is about designing experiences. And that's why sound design is very interesting, because sound is an experience, right? It's something that you feel, and when you're in a room or in a space, outdoors, indoors, you want to feel something. And like I said, I don't know a lot about sound, but I know what it feels like to be outside and either have good sound or bad sound, or in a room and have something that sounds terrible and gives a nasty experience, or sounds amazing and gives a really good experience. I did have really cool animations on these slides as well. Just pretend that it's animating and it's amazing. There were fireworks and there was like falcons flying in, and it was a little bit better than this though. A really good example of this is the difference between superblocks and study art. So this is downtown Abu Dhabi, which is not very beautiful. It's just a lot of buildings. It was actually modeled off New York. So the ruler of Abu Dhabi at the time, Sheikh Zayed, literally went to New York. This is 1950s, 60s, and was like, this is good. Those straight roads are cool. Let's just do that. And so they designed these things called superblocks, which are really interesting. You can kind of see these giant blocks here. The idea of a super block is it has everything that you need. It has a mosque, it has a school, it has a hospital, it has places to eat, and it has residences. And on the outside of a super block, you build all these tall towers to kind of block the sun and channel the winds and everything. So these super blocks became the building block of Abu Dhabi. Super functional, not very beautiful, and in this period of time where there was no identity. They just needed to build and needed things done. This is about 5 kilometers away. This is Saadiyat Island, which some of you have probably heard of. This photo is probably about 6 months, 4 months old, because this project here, TeamLab Phenomenon by TeamLab in Japan, has just opened in the last couple of months. And here you have the Louvre, you have the Abrahamic Family House, you have the Guggenheim, you have the Zayed National Museum, you have the Natural History Museum, you have TeamLab, and you have a whole bunch of insane projects, like multi-billion-dollar projects going up on this island, all dealing with really unique individual spaces. I've stood inside most of them, and some of them sound amazing, some of them sound terrible. But the whole island is this kind of testament to having a really bold vision, like a really crazy thing you want to do, and just saying, go and do it and figure it out. And that's just a little sample of what's going on in Abu Dhabi. There's a whole bunch of other ones. These are supposed to go like pew, 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 and animate in, but just pretend that happened. You guys would have seen the Formula One, UFC. We just announced that Disneyland is coming to Abu Dhabi in the next few years. You've got crazy immersive experiences like TeamLab, where you've got moving digital screens and sound and all this crazy stuff happening. You've got cities like Mazda City, which is supposed to be fully sustainable. Like all these projects that are all trying to do something unique and something different, but always with this question of identity. Because they're very, very aware that they're building the future of the country and the future of the nation in a way. And so it can't just be copy-paste from what happens overseas and dump it on an island in Abu Dhabi. And they're literally building islands. That's the crazy thing. They will literally build an island to put new houses and new projects on. And the next one. These are also supposed to animate. The red stuff wasn't supposed to be blocking the words, but I think you can read there, technology and identity. So this is a huge part of what we do, is understanding that you need the best technology, you need to build with the best materials and the best engineers and the best architects and the best whatever you need, but it also has to be a conversation about identity. You can't only have this at the sacrifice of this, and you can't only have really amazing identity, but then have really terrible, terrible quality projects. In design, it's this common conversation, form and function, that we need to look like it's us. We need to look like it's from the Emirates, like it's Emirati, but it has to work. It has to be functional. And there's a few projects that I want to, oh, the time's counting down. Oh, wow, okay, I gotta go fast. Okay, there's a few projects I'm gonna run you through very, very quickly that are really good examples of this, and this is your invitation to Abu Dhabi. If you wanna come through, you need to go and see these spaces because they are phenomenal. So, first one is the Louvre, Abu Dhabi. Obviously, the only other Louvre is in Paris. I'm never sure when I say Louvre if I'm saying it correctly. Sometimes I say Louvre, sometimes I say Louvre, and I just kind of go with it, and people seem to know what I'm talking about. So this is a phenomenal space. There's a really, really cool story about identity, how the architect, Jean Nouveau, went to Al Ain Oasis, which is about 2 hours from Abu Dhabi, and he stood under the palm tree canopy of the oasis, and he watched as the light kind of came in through all these crisscrossing palm branches, and that's where he got the inspiration for this massive dome, which covers this whole village of galleries. The village underneath is a big mashup of different buildings, all configured in ways that create alleyways, which are called seekers, which is very much the way that they used to design Arabian villages that capture the wind and kind of funnel it. Underneath the dome, it's about 7 degrees cooler than it is not under the shade. And so you can be like a 40-degree day outside, which I've just come from, very, very uncomfortable. And under that dome, just because of shade and passive cooling, it can be 7 degrees cooler. But it is an absolutely phenomenal building. I've had the privilege of touring quite a lot of really respected international architects through here, and it's always absolute wonder and amazement at the size and the scale. Like, it's big and it's bold, but it's really, really beautiful and super, super tasteful. And we always say this is a really timeless building, that in 20, 40, 50 years, people will look at this building and understand that it feels like it's from Abu Dhabi. Just across the road is the Abrahamic family house. This is a project that we were lucky enough to collaborate on with the architect. We did the branding and we did a few other bits and pieces. But it's a mosque, a synagogue, and a church all on one site, all connected by this podium-level garden thing, which you think about in Abu Dhabi, in the middle of the Middle East, having a mosque, a synagogue, and a church on one site together is quite a bold statement. And the architecture reflects that. You can step inside each of these halls of worship and just feel like complete serenity. You can hear the call to prayer, you can hear the church choir singing, you can walk through these spaces, and a lot of people talk about this being a really holy site. It feels spiritual when you're there, and there's so many different expressions, whether it's through the materiality, through the way that they've designed the building, that feels like Abu Dhabi. It doesn't feel like this could be copy-pasted anywhere else in the world, and it's another really good example of using the best technology, the best architect, the best everything, but saying, what does it actually feel like to be from Abu Dhabi? Just down the road from there is the Founders Memorial. This is a tribute to the late Sheikh Zayed, who was the founding father. This was a project that is an open memorial, and I'll talk to you very quickly about it, only because all of the landscaping there is natural indigenous species. And so we had a guy we worked on this project with who was Danish and is an expert in his field at doing landscaping and stuff with trees and plants and things. He came to Abu Dhabi and he failed multiple times because he was trying to bring grass and all these amazing, beautiful flowers and roses and stuff, and they kept on dying because it's 40 degrees outside. And he actually went on a sabbatical for a year and sat down in Abu Dhabi and studied the local species, local nature, and basically became an expert in local endemic species, and then came and designed this, or helped design this, which uses all these local native species and completely changed the way that it is landscape and the way that it fits into Abu Dhabi, which is just a nice little example of someone putting in the time and the understanding to know what this should look like. The last one I'll share is Qasr Al Hosn. This is the oldest building in Abu Dhabi. This old fort here, it's like 1761, which is probably not that old considering like the rest of Portugal and where we are today, but this is old for Abu Dhabi. On the site is this old fort, which has been renovated. There's a super cool cultural foundation that's kind of a brutalist, modernist building. And then there's this new section of landscaping and cafes and stuff, which has been designed by a Danish architecture firm called Zebra. And this is a really excellent example of 3 completely different architectural eras, all on one site, but all pointing towards the identity of a place. That when you walk on here, you feel like, yeah, there's something that is understood, whether it's the nature, whether it's the design, whether it's the way that sound even carries across the space. It's really, really well done. All this to say that, and this is not going to be as cool because the animation's going to ruin my amazing build-up, but you'll get the point, is this is my message for today, and this is what I hope to bring you from Abu Dhabi. And look, I guess this applies to most places, but it's really important for where I work and the projects that we do at Slash, is this was the old argument of Abu Dhabi and Dubai. Best practice is that you have to have the best. You have to go outside because there's no local architects, there's no local urban planners, there's no local sound designers, there's no universities teaching that stuff. So you have to get the best practice from overseas. And it's good because it managed to build a city, and there's amazing experts and architects out there who do have the whole best practice thing. But now it doesn't make any sense without that. You can't have an Abu Dhabi best practice without understanding what the local identity of that best practice is. The same way as you can't have local identity without actually making it really good, because they have the resources to make it amazing, but they want to make it amazing for there. And so it's more of this kind of conversation. Best practice with local identity. The question of how it works, but how it works here. And this, unfortunately, we've been involved in enough projects to see it not going that way, to see the best practice coming in and someone saying, no, this works amazingly in Europe, this is exactly how we do it, and putting it there, and the client says, yeah, but this is not Europe, this is Abu Dhabi, this is the UAE, we can't have it like that. Whether it's an architecture or planting and design, whatever, there's a lot of mistakes that have been made. Education systems are now currently looking at what the new education model for the entire UAE looks like, because the schools were British and American curriculum because there was no education system. So it was like, okay, cool, we need education called British curriculum, like boom, American curriculum, boom, like it's working. And now it's like, well, what does Emirati education look like? Because best practice worked for a time, but that is not sustainable, not if you want to grow a nation and get to a point where you say, this is Emirati, and that's the conversation that's happening. There is no architectural history to reference, which is a massive challenge. There's no century-old design principles, which we work a lot. We're a strategic design studio, so we don't just try and make pretty things. We try and justify them and have a strategy and a reasoning behind them. So the design principles that we use to design a building or to speak to an architecture firm about how their building needs to adapt to the local climate, they have to come from somewhere else. And we're really lucky that the leadership is very, very set on the culture and values. I assume that in somewhere like Portugal, you can look out the window and you can see the architecture and you can kind of say like, yeah, we have a style, we have a way that we say, yeah, that looks Portuguese, whether it's the color or the materials or the way the roofs are built or whatever it is, and you can kind of copy paste that moving forwards and something can fit into that. In Abu Dhabi, we don't have that. There's nothing we can point at that we can say, yeah, that's our architectural heritage. So we use the culture and values to try and define what something might look like, which is quite tricky, and it's very open for interpretation. We're really lucky in that we work almost exclusively with government and with leadership, so we hear the vision from the people at the top, and then it's our job to translate that down into what it looks like, what it tastes like, what it sounds like, what it feels like. Because like I said earlier, like they want to design experiences. They're done designing buildings. They want to design places and experiences where people feel at home, where they feel they want to stay. That's another huge conversation that's happening in Abu Dhabi at the moment for the last 10 years is the word livability. As you used to come to the UAE on like a 2-year visa, and you would do your job, and then you had to either apply for another 2 years or you just disappeared. And now they want people to buy houses. They want people to have kids there and to live there forever. And how do you do that if you don't have places where you want to live? You don't feel like, I come from New Zealand. It's very, very different from the UAE. But their challenge to me is like, we want you to live here, so what do you need to feel like you can live in a place? And what are the experiences you need to design? What are the places you need to design that don't feel like New Zealand, because we're not in New Zealand, but they feel Emirati, and they feel like somewhere you can stay. So I'm going to run you very, very quickly through an exercise that we gave to the same architects that were sitting under that mountain with us, the 40 different international consultants. When they asked us, well, like, what is Abu Dhabi? What are the design principles? This is what we gave them. And I'll just be... just a little disclaimer that this was kind of also comparing what Abu Dhabi is to what Dubai is. So there's a huge contrast between those two places, even though they're an hour and 15 minutes apart. This is also a little bit of a dig at Dubai, which if there's anyone that knows anyone in Dubai, just don't tell them that I showed these slides. And this is called the we are not, as you can see. Abu Dhabi, we are understated, pretty humble and low-key in the way that they design things. We're not obvious. And this is a library in Dubai that's designed like a book, because libraries have books, and of course you would design a building that looks like a book. So you look at it and go, it's a library, it's a giant book. But that's not how Abu Dhabi design things. It's not in your face. Abu Dhabi is brave. That is the arches of the mosque and the Abrahamic family house. I think with the situation that's going on now internationally and politically, like designing the mosque, synagogue, and church in one space is pretty insane. But they put their money where their mouth is and made this space at the same time that they signed a deal with the Abrahamic family accords to try and have that conversation. It's not opportunistic. It's not a Las Vegas where it's like, just build cool, crazy things and people will come and we'll be a tourist city. It's not that place. It's humble, even though the buildings are quite massive and can be like completely out of control. The new way of building is quite low-key, it's quite refined. It's not there to scream and shout. Down the road, it can be a little bit more crazy, a little bit louder, a little bit more in your face. And again, both these places are Emirati, and this is a complication of the conversation, is they're both Emirati places, they're an hour and 15 minutes apart, but they have different perspectives of looking at the idea of identity. Abu Dhabi is very crafted. They love detail, and we love talking about the craftsmanship idea and the time it takes to do something and the quality of something. Quality is a massive word. It's not glossy. It's not shiny. It's not plastic. It's not fake. It's not, an off-the-shelf kind of solution. It's narrative-driven. We love stories, and we love the idea that there is a past and a history and a culture that we want to connect with, and how do we tell those stories and connect them to the projects that we're doing today? It's not superficial. It's not like this is a fake souk, which is a market in one of the hotels in Dubai. This idea of like, what's all the things that the tourists will like, and let's put them there and people will come and buy the fake Arabian lamps, which I'm sure they never actually had in the Emirates, 100 years ago, but that's not it. We're not looking for the easy, pretty things. And lastly, it's people first. And this goes back to the point I mentioned about livability, is there's every nationality in the world, it feels like, lives and spends time in the UAE. And so how do you build for those people? And how do you make sure it's not impersonal? And that's really, really interesting when it comes to these like mega spaces and islands like Sariyat, where you're inviting people to go and kind of saying like, how do you create these really personal, intimate spaces while they're still mega projects and still insanely beautiful and grand, but how do you make them feel personal? And I would imagine sound design has a huge role to play in that. That conversation is not happening a lot in Abu Dhabi. It's definitely a market that needs to have that conversation, but it takes a lot of time and a lot of sitting in front of people and explaining why that's important. It can't be done over Zoom calls. All of these design principles lead to things like this, where we sit in front of a client and instead of providing them like schematics for a building and saying like the square meter, we provide mood boards and we say this is the direction that we're heading in. We kind of sketch out ideas and feelings to try and engage them in a conversation about what they want the space or the design or the experience to feel like. And these are not our buildings, these are not all our pictures, but it's a way of us expressing to them or working with the client to say, oh, what do you want it to feel like? And then we have a starting point for the conversation, because briefs are also notoriously quite crazy there as well. And you said we work a lot with like tones and colors and materials, but this is not at all like that very first slide of the UAE kind of misperception that I talked about. This is a lot about trying to understand this new identity. And lastly, as I finish up, wanted to leave you with something super, super practical, thinking that probably some of you might already work in the UAE or want to work in the UAE. There's like the practical tips for like what to do and what not to do. Oh wait, no, it's not. Oh wait, first, real quickly, sorry, I got ahead of myself. Real quickly, 2 examples of really good local projects that are using local materials and like innovation to build crazy cool new things. The first one is Datecrete. This is the UAE pavilion in Osaka at the moment. These on the floor are all date pits, the inside of a date, which we have a lot of in the UAE. And I've created this really amazing material, kind of a concrete resin material, to make tiles and concrete and blocks out of, using this date material and obviously connecting to a very local story rather than just importing concrete and doing it that way. The second one is Barzak by an architect Wael. It won the Venice Biennale Golden Lion in 2021. And this is the waste product brine from desalination. So we desalinate a lot of our water there, and he was taking all that brine, he was combining it with the waste from building sites, which we also have a lot of building sites and a lot of waste from building sites, and with palm fibers to 3D print these massive structures. And this is an artwork that was on the Corniche in Abu Dhabi, but it's a really interesting project that he's now looking to scale up into the facades of buildings and understand how he can use these waste products to actually kind of tell a local story and build something locally. And these are just 2 interesting examples, obviously not in sound design, but in ways people are using local material to design. So I guess my question is this, that what does best practice and local identity look for sound design and acoustics? And I don't have the answer to it, just to be clear, I'm sorry, but I guess that's the question for you to answer, is that if you come to Abu Dhabi, when you come to Abu Dhabi, or when you work anywhere, is how do you take the best practice, the knowledge that you very clearly have, because I had no idea what anyone was talking about this morning. It was like a lot of graphs and things. I was like, wow, this is really impressive. Don't know what it is. But how do you take that and understand what identity looks like through sound design? And last slides, some of the lessons that we've learned at this intersection of architecture, culture, and local design. Avoid Google. Don't Google things and then stand in front of the client and explain to them about their place from Google. We've had some really awkward situations where someone has presented to a member of the ruling family a photo of themselves and it hasn't been them, and it's just been awkward. This was a term that both my CEO, Nuno, who's Portuguese, and George used to me when we were talking about this talk, is wash your brain. Like, wash out all the misperceptions and all the things you think you know and just start afresh, because what you think it is probably not what you think it is, and those ideas will trip you up. This idea of innovation and disruption. Innovation is like a super cliche word at the moment, I think, but this idea that it is an amazing place to be able to innovate and to disrupt the way you do things. It's really interesting the amount of conversations we have with any consultant that comes in from the outside of, no, but this is how we do it. This is how we do it in America, so we'll just do it like that here. And it's like, no, like they want something different. They want you to try something different, and there's room to experiment and to try things. Don't just come in with the, oh no, but this is how it works. Embrace the tensions between holding tightly to the past while stepping bravely into the future. And briefs change. For anyone who's ever worked there, you know that briefs will shift, and you have to be okay with that. The briefs can be a WhatsApp message, and then a few weeks, months later, it can be like, no, it's not that, now it's this. And the amount of people who say, like, no, like I signed a contract, I can't work, and the client is like, doesn't matter, it changed, so deal with it. You have to be nimble, you have to be ready to adapt and ready to change course. And the last one, forget low-hanging fruit. This was a phrase that was used a lot by leadership, this idea that all the easy things years ago were there for the grabbing. Like I said, we needed homes and schools and roads and spaces, so it was easy to just design those things because they're the same as everywhere else. But that age is gone. There's no more low-hanging fruit anymore in the UAE, and now they need people who are willing to invest a lot of thought to spend that year researching and understanding the local culture and context, and propose things that are quite audacious, because you've seen the different projects that are happening in the Emirates and further afield, Qatar, Saudi Arabia. They're like really audacious stuff. Some of them work, some of them don't work, but they're willing to have that conversation and to throw those briefs out there and to see how they work. But you have to be willing to engage in that conversation locally and not treat it as easy money, do some designs and disappear. And I think that's it. So hopefully that made sense. Thank you for listening. And if you have questions, I will do my best to answer them later on, I think. But thank you.
Yeah, okay. Thank you, Jonathan. And again, apologize for the presentation mistakes that we used the PDF instead of the keynote. So sorry again, and for not giving you the notes. But I think you managed pretty well. Yeah, maybe better without the notes, but who knows? Maybe you should thank us. I'm kidding. Before we continue, a few words from someone who also cares about thinking things forward. Please enjoy.
Artnovion, and why Artnovion? Is a huge question because it's it's more than actually building a brand. It's about falling, in love in life. So that's the main thing. Because when we do something that we love, so we don't lose that energy. So I wanted to deliver acoustics in a different way, not just a traditional way, which is the most of the guys 20 years ago they say, well, the acoustic must be ugly, but it performs. And Artnovion is not about that. And sometimes the beauty is an opportunity. How many times we found inspiration from the nature to build science. And Artnovion is a sign of that too, because if you see the name of the products we do, it actually comes from inspiration from the nature. So we have a product called Alps, and it's a diffuser. So, and that is the project about Artnovion, from science to deliver to the world, the best product in acoustics, but it with the best quality, the best shape, and of course, beautiful as well.
So our next session will explore how acoustics behaves in very different environments. With us is Donato Masci. I think it's Masci. Yes? Masci? Yeah? Good. With whom Artnovion has achieved extraordinary milestones in the world of science and engineering. So we are only wait a minute to check if everything is okay, because we don't want to mess another presentation. This is we only have more too, so we don't want to screw this one. So please stay 1 minute. You can breathe, drink water. Yeah, just 1 minute. And when we all set, I will call Donato, and we are going to continue.
d'aller en grand braquet. Tour de France, sprint final à l'arrivée. Tour de France, Tour de France.
Hey, good afternoon all. So we are just changing a little bit our plans. So sorry for that. We ask you now, you doing the coffee break, so people want to enjoy more and more outside. So, and this session, instead of being right now, will be after the coffee break. So now we put together 2 sessions, then we go for the round table. Okay? So upstairs, you just go on the left, and you can go for a small coffee break. Okay? Thank you very much. See you soon. We must be here in more or less 20 to 30 minutes to make sure we fit all information. But I know it's a bit tiring, but, you know, that's it. 20 to 30. Thank you very much. Speak to you soon.
don't fuck with you. Shall I go or shall I come? Live from Badoobletron, loopy info normal none. On and mama's done. Underwater eel motherfucker, all the other son. 214, all in my phone. We from Dallas, baby. Freak zone.
Artnovion, and why Artnovion? Is a huge question because it's like it's more than actually building a brand. It's about falling, in love in life.
3. 1, 2, 3. Oh, okay, okay. This is probably my third or fourth Artnovion conference. I always talk about small spaces, low frequency in recording studios, etc. And today, this is an idea that came from some discussion with Bruno Fazenda. We talk about large spaces, and it is fun because there are some facts that are in contrast between the small and the large spaces. Of course, something changes. In particular, the ratio between the wavelength and the spaces, of course, it changes a lot of things, but also in the way that we have to design these places are quite different. So let's go on. 2 words about my company, Studio Soundscapes, an acoustic design company located in Florence. I go on because today we are a little bit in rush. We are 6 people plus some collaborators, quite different. I'm a physicist. Cecilia, my partner, she's a civil engineer. Then we have building engineers, an architect, communication specialist. So we are a small team. Sorry for this, probably I don't know if you read it, but we came from the recording studio design, but also for post-production design. So we design a lot of studios for dubbing, starting from Italy. That is a place where the dubbing is very important. But also we start working all around for big companies like Ayuno and Dubbing Brothers. So we design rooms from Burbank to China for dubbing and theatrical mixing room. But of course, I came from music, so I like it. What has changed in the last years is that we started the company, started in 1983 with Fabrizio Giovannozzi. I entered in the company in 2008, and from that data, he was an electronic guy, so he started doing services for mixers in the 80s, and then he started doing also acoustic design for studios. I take his heritage, of course, but we changed something, and now I can say that we do half and half of invoicing about audio facilities, so recording studio, post-production studio, cinema, and architectural acoustics, such as theaters, auditorium, hospitals, schools, and many other things. So in the last years, we changed a little bit what we do. We have a representative in Saudi Arabia and some representative around, and we did some work basically in Europe, and sometimes we do something for big companies, say Ayuno in USA and in Asia too. We are Dolby certified service partner, the Italian Dolby certified service partner, so we can do certification and commissioning for all studios listed by Dolby, and also CD associate. That's all. Go on. Okay. So in the first part of this presentation, I will talk about the philosophy because there are 2 words in contrast, small rooms and large halls. And this is a funny part, but I always say that when there is a journalist in Italy and it goes to do an article about something about acoustics, so there is a theater or a studio or something, the day after always write acustica perfetta, which means perfect acoustics. And it's okay, we are all happy about this. But in a few words, perfect acoustic doesn't exist. We only need appropriate acoustics for specific purposes. And this is very important to know, of course. It seems easy, but not so easy to know for the people. And the philosophy is different. In small spaces, in a few words, we have to reveal the truth. So we want to cancel every kind of coloration of the room to hear the perfect sound of the speakers at the end. Of course, this is not like a Taliban thing, but because, of course, a little bit of room, it's always needed. But the idea is having a more transparent reproduction of the speakers. For large spaces, it's totally different because the whole must recreate, create the magic, can enhance the content with natural amplification maybe of the sound. And so the coloration is, the room is worked like an instrument in this case, and so is a totally different approach. So same consultant, opposite roles. When we work like a studio designer, we are the architect. So it's not only about acoustics, it's everything about us, because we choose the interior design, we choose the ergonomics in the room, we choose almost everything. When we work for a theater, for example, we became theater consultants. So we collaborate with an architect, and at the end we have 30% of control of the things, because of course we cannot put our hands on everything. But you know, recording studio is like Formula One, so probably another important point is that you need to design the things to have a very perfect listening position at the listening point. That also this is not properly real at all, because of course the people should listen also in other part of the studio, but in general it's like this. As a theater consultant, you need to do, but also if you do a home theater, as D'Antonio says this morning, it's not only about one point, one position. So you need to adapt in multiple acceptable points in the room. So there are differences in the approach. There are also, we have to say that, for example, in Italy, we have a lot of acoustic engineers. No many of that of those are working in room acoustics, but who works in room acoustics is divided between studio specialists and concert hall designers. So it's very hard to find someone that do everything, because it's quite different, really quite different. Okay, so when physics dictate design, what does it mean? We talked this morning about Schroeder frequency, which is a frequency related to the reverberation time and the volume of the room, that it's very important for the philosophic point of view, but also from the physics point of view. Why? Because above the Schroeder frequency, in general, we use statistic. Below the Schroeder frequency, we can use the modal behavior. We can better work with software such as FEM, BM, or something like this. Above, we can use ray tracing or other software. There are some software now that makes everything, as the professor says before. Like we are going to use Treble now, that is a software that combines wave acoustics and ray tracing in the same software, of course, and it seems to work quite well, both for small rooms and large hall. But in general, when we design a small room, we never do a ray tracing. When we do a large hall, we never do a FEM model like with comms or something like this, because this is a completely different approach, because for small rooms, the modal behavior is the most important part. Low frequency are really different things to manage. And why this difference? Because it's all about the size of the wave, so the wavelength in comparison to the whole. If the wavelength is on the same size or bigger than the whole itself, the wave acoustics should be, you have to work with this. If the 17 meters, that is the wavelength of 20 hertz, is not a problem for the whole because it's very big, probably you don't have a lot of problems of low frequencies. So another important part is the bass. When we talk about bass in studios, we talk about 20 to 200 hertz. When we talk about bass in concert halls in general is, well, sorry, it's cancelled, but trust me, it's about 125 to 150. Is something different when we talk about coloration of the room. But the main problem is that in the studio, we try to use a way to control every mode in the room. In the concert hall, we have to be very we have to be aware of this because, of course, there are some effects like the seat dip effects that it's a lot of low frequency in the room just for the seats. So what happens, for example, in also in ancient opera houses in Italy, we can see it, that low frequency are not enough. And so this is happening because of some resonance happens in the finishes or maybe in other parts. So for concert hall, we have to be aware to leave some panels resonating in the room. For studios, we need them a lot to control all the modal parts. And the diffusion also is different. We talked, D'Antonio talked today about diffusion. All his experience, of course, in studios is very important for first reflection point, the rear wall. We always use diffusion, even if we use maybe less diffusion than others, for example, but it's always needed in a studio and is accepted. And in particular for live room, we use a lot of diffusion. So it can change between the control room, live room, but diffusion is a precious thing. In concert hall, you have to be aware because if you put a lot of diffusion on the sidewall, for example, can be a pity because a lot of sound energy coming from the side can be reduced in a way. And so the lateral fraction of the sound that gives us the idea of the spaciousness can be reduced. So we have to be aware about this. Oh, sorry, wrong button. Can you help me? Thank you. Yes, sidewalls, as I said. Let's go on. And this is another very important part that also tomorrow we talk about this. Why every simulation starts wrong. So you do the model, everything is fine, you push the button of your software, and the numbers are at the beginning. Why? Because, of course, you have to tune the model. You have to calibrate the model with the good inputs. And what are the main important inputs? For small spaces is the impedance, or the admittance, of course, is the same. It's not the same, but one versus the impedance. And so having the impedance values of the boundaries of the walls is very, very important for the low frequency simulation. In large spaces, you need an absorption coefficient, of course, but it's not like simple like it is. For example, if you go in a cathedral, you can design the room in a very simple way, but at the end, it's not like this. It's a lot of things on the columns, the statues, and everything. And so at the end, even if you say, okay, I can design like flat because there is no scattering above, okay, but at the end, the final result of the surface is much more than expected, and so the things can change. So, in my opinion, the future needs a systematic calibration approach. That will be very, very important, because now it's a sort of trial and error. We do measurements, we do modeling, then we see results, we match with the measurements, okay, we can do better, so we can do better, we restart, we change the alphas, we change blah, 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 blah. It's a very long process, and maybe after some days, because we don't use Nero, but maybe. But of course, also for large spaces is a long process. And we need to, AI can really help us for this kind of situation. So that's what I need. For studios, the modes have to be eliminated, in halls preserved, diffusion in studios is strategic, halls is minimal, lateral energy in studios in general, we destroy if we not scatter a little bit. In halls, we have to preserve. In studios, the materials are more absorptive, and in halls, reflective. And the panel mounts in studio can be resonators, so can absorb low frequency, and in halls have to be rigid. Otherwise, a lot of energy can be affected by this problem. So, talking about small spaces, today we see a lot of things, and of course, what happened is that we have some weapon, we have some instrument to simulate properly the low frequency, where the acoustic field is deterministic, is like quantized from the modes. So it's not easy, of course, but we can go into deep, we can measure them, and we can kill them in a word. So that's quite, it seems to be easy. It's not easy, but we can do. So the software, we have everything to do. We need more power probably for calculation, but so we try to find an idea to evaluate the impedance indirectly with a very simple way. This idea came from a long R&D work that we have with BNC speakers, a transducer factory located in Florence area, and also PowerSoft and KRA, where we try to do an active absorber, and we did it. Works very, very well. Then, of course, the company decided to, that was quite expensive thing, and so was not put it into the market. But it works so well, and we did a lot of simulation about this. At the end, what we understood is that it works like a normal absorber, and so we developed some tools in Comsol to do this. But the most important part is that we find a way to evaluate the impedance coming from only a few measurements in the room. In this paper, you can find the formula that correlates the modal decay time with this modal participation factor, epsilon, of every mode, each mode on every surface. And then, calculating this epsilon value, you can assign impedance on every wall. Of course, it's like an equation system with n unknown variables that are the impedance and MT60, so modal decay time. And it's not easy to evaluate a lot of modal decay time, because if you go on over 60, 70, 80 hertz, in some rooms, the modes degenerate together, and so it's not easy to match that particular decay time for the, oh, sorry, wrong button. Can you help me, sorry? Okay. So this is quite hard to explain, but we find some strategic position of measurement in a room, in a rectangular room. The room is empty, so it's a very simple system. If the system would be different, it can be completely difficult, more difficult to solve this system. But in this case, it works. And so we decide to evaluate, for example, the first mode using the pressure measurement in that position. For the second room modes, we evaluate the room modes in that position. Why not in these ones, for example, also because it's a maximum, because in this one we can find a maximum of another mode. And go on. And so we have 4 different impedance walls, and we evaluate the MT60 on every kind of impulse response that we have. So we average them, we put in the formula with the modal participation factor, and we took the impedance. We took the impedance and put in console again, and the result, sorry, and that's the result. The red line is the measurement in the room. The green line is the simulation with console using the acoustic impedance. The blue line is the room with rigid walls. So of course there are some discrepancies, for example in this part, because we have resonances of the gypsum board. That should be really improved, because in this part we evaluate the impedance like rails. So the imaginary part of the impedance have to be improved. We try to do something different, evaluating putting some evaluation for impedance with some software like AFMG SoundFlow, and we find something interesting like the pink one, or maybe I don't remember one, but trust me, at the end, with the simple situation, we have a system with which we can work and simulate the low frequency. And we do some nice things, for example, using Artnovion resonator panel, with which we do a lot of studios all around the world. And from this software, you can see, of course, the pressure, as saying with all the other software shown today, and gives you the idea where you have to put some other things. And you can evaluate also the pressure inside the room. That is very nice and not so easy to understand, but it's quite interesting. Where you have bright, stronger colors, you have maximum of pressure. And with these kind of things, we design not only a very small room. For example, this is a big one. It's the biggest theatrical mixing room in Europe, Cinecittà, where Federico Fellini mixed a lot of films in the past. We redo it from scratch in Dolby Atmos. And but we design with the same approach as the small rooms, using this kind of resonator panels, all different tuning, you see. Also in the ceiling, and just to show, the resonator panels are like this. Are not membrane absorber, are more panel absorber. There are some layers that we use. This picture are a little bit retouched with AI to don't show something, but it's okay. The idea is that we have this kind of panels that helps a lot with low frequency, but it's not easy to tune the low frequency absorber like panel or membrane absorbers, because the clamping of the membrane can change a lot the behavior of the panel itself. And so other rooms in the same way in Cinecittà, just to give you a complete picture. As I show you, and as I said before, we design everything. So also the interior design is everything about us, because every time it should be, can I do this? No. Can I do this? No, yes, but you can change a little bit. Okay, can you do that? So the architect is the architect. In this case, we are the architect. But for theater, it's different, of course. In this case, they asked us for doing a sort of very nice thing like Millennium Falcon. Yeah, exactly. It's Cinecittà is the Italian Hollywood, so it makes sense. And this is the medium-sized room. For me, it's the best sounding room with a Mayer sound system, yeah. And go on. Just to give you an idea, this is a nice guy and very important engineer in Italy, which made a lot of Dolby Atmos Dolby Atmos mixing, also Maneskin, or a lot of important Italian artists. We designed an Atmos room for him, but what is important to show is that in this case, he was used to work in phonoprint. It was a room designed in Bologna by ADG, so Flynn and Toyashima, and they are used to work with base traps like hanging panels, plywood with polyester fiber. And he wants to use the same technology because he's very used to work with this part. So we changed our way to work, but the basic philosophy is the same. So we put the absorption in the same place, we calculate this part. So at the end, of course, the device is important, but the philosophy behind it is also more important. Where to put the things are more important. For example, for this room, we use membrane absorber, all the membrane absorbers, and so just as a show reel for DJ studios that are quite flashy. And this is something in the middle. You can see from this kind of picture that is not only a small room. And as you can see a lot of absorption on the sidewall. It always is wood. Yes, there is some absorption on the low frequency because these are resonators, panels, and etc. This is a slat absorber. But at the end, there is not so much fabric as the small room. Why? Because for the live room, these are in the middle between small room, like control rooms, and maybe theaters. So the approach can be in the middle. So we have to use our small studio experience, but also taking from the big ones. This is the same for this. So talking about the large spaces is different, where the statistics rules is statistic behavior. Go on. Yeah, this is an important fact. When we do, as I said, an acoustic CAD, maybe in EASE or Audion 3D model for a cathedral, you at the end should measure a surface that is maybe also 60% less than the real one. So, okay, you can say a lot of things like, okay, but if you don't have a discrepancy of more than 2 centimeters at the end, it's not scattered the highest frequency. Yes, but at the end, the surface is much more than the existing one. And this affects the final result. That's the reason why if you do a lot of measurement there, you do the model, you put the absorption values coming from the book, and at the end, the reverberation time coming from the thing is about 60% longer than the real one, even if it's much longer. This help, for example, this happening for I will show you. So go on, sorry, on this. Sorry. I make it, okay. So that's a big problem because in this case, we need a lot of time to do the modeling and also to calibrate this, to make it work like the measurements. It seems fun, but 70% of our time is this, and then 30% is acoustic design. And it seems to be fun, but it's very, very important. This is the reason why we need tools like yours, of course. And Duomo di Siena is the Siena Cathedral. This happened. What I mean. In Siena Cathedral, there is a very important mosaic in the floor that is covered by a thin layer of carpet all over the year, except 2 or 3 weeks that they open to show to the people, but they have to recover. I don't know why, but I think because it's so precious, and of course the people are working on it, and so. We designed for the floor covered, and at the end, the reverberation time was not so long as expected. Was like 7 seconds. Of course, in the low end is like 10 seconds, but it's not like 20 seconds that we have in Florence Cathedral, so it's quite different. Funny part, when we design the things in EASE, we find 11 seconds for the reason that I said. So it's not only about the hidden surface that are not counted into the things, but also because the material during the ages, their crackers are not like marble 0.01 that you find on the books, of course. So you need to calibrate in a way. And it's a long process. It's really a long process because when you have to change the alphas, you have to think, okay, which kind of alpha I have to change? Floor? Ceiling? Yes. Walls? Yes. And you have to use your experience to do this. And it's not easy. It's not easy. And of course, if we have a strategic calibration tool, maybe some measurement that can accept, and this is what I would like to say at the end of the presentation. So of course, just to have a complete picture of this is the 3D model, very simple for the room. Of course, we cannot do better, of course. Now we have cloud point models for Florence Cathedral. We will start from it, but it's hard for the ray tracing software to do a simulation. Maybe Treble is a little bit powerful for this, but it's hard. And so we, of course, in this case, we simulate the beamforming for the control directivity line array, and we put in the software, blah, blah, blah. This is the story, just to have a complete picture of what we did in this work, of course. In this part, it seems to be easy, but placing these in a cathedral like this, it's 6 months of papers with the superintendents and major and the biggest priest and everything, all the people in Siena. So that's the result, and the final simulation was really consistent with the measurement that we have. So they did the things only in the main part of the church. So, as an acoustician, we are called to work for theaters in Italy, and we have several old theaters, like old small opera houses not in every town, but we have plenty of these. For this case, we don't have to touch so much, but we have to be aware to the material. For example, during the ages, during the years, the idea is, okay, feel with, feeling, every kind of feeling with, for every kind of fabric covering. Maybe we change the seats, and then we put the seats with filling on the back. These kind of things change the behavior of this kind of room. So we have to maintain, like an archaeologist did for this kind of things, and we have to maintain also the behavior of the materials. That is very, very important. In particular, when we would use these opera houses also for symphonic music, that is not proper, of course. We are talking about 1.5 seconds versus 2 point something. But in this case, it's easy to go down to 1 if you put all the fillings, all the carpets, and all the velvet around. So we have to be aware of this. In this other situation, for example, this is Theater of Pistoia close to Florence. We changed this part because in the last century, they changed the last 2 tier of boxes with a gallery going up to this to enhance the number of seats, and it was a mess because you can see, you can hear anything from here. And so we with the archaeologists and with the architects, we decide to come back in the original design of the theater, and so to go back to the last 2 tiers of boxes. And this is one of the few new theaters that we are going to design. In this case, we have to fight with the architects in general because, of course, every time, okay, let's do like this. Okay, wait a moment. And so it's another time when we have to match and see what happens with the scattering of the panels. And also for very simple drawings like this one, this is the small room, is very easy drawings, but you can work behind, for example, using fabric to cover something. The architect wants something, and you can work behind in this case. So this is a completely different approach than recording studios, where you have to do whatever you want. Not really whatever, but... And so yes, a recording studio. The artist, engineer, done. Make it sound good, it's okay. For the theater, it's very long process, and it takes like years to choose what you have to do, what you have to place, what you can remove, if the color is right, and everything like this. Go on. I want to show you an experience of a middle-sized room that is a hall used for the Florence Conservatory. So it's not a big room, really big room, but it's not a small room. So this is a room where both our experience are used and also the approach on the heritage room, let's say like this. This was the room, before. They have a dome with glass on top. And reverberation time was long, but it's not the biggest problem, in my opinion, is that all this dome is focusing a lot of energy in the center of the room. And when you go all around here, it's not so easy. Then it's a completely masonry and concrete room, so it's a lot of very low frequency in the room. So we decide the reverberation time that we can have in the room, because they are doing lyric music there, but also school and some electronic music, like for classical, not like David Guetta, of course. But, we make measurements. We have like 3.5 seconds of reverberation time, quite long, but as I said, the real problem was not like this. And this is the result. Can you see the differences? Yes, the curtains. Let's go into details. We took 3 types of treatment. The first is the curtains, of course. The second one are resonator panels. There, completely covered by fabric of the same color of the whole, of course, of the plaster. And the second one are transparent canopies that helps the room to avoid the focusing effect of the dome. Coming from the reverberation chamber experience, where we put this kind of canopies, I will show you better because it was really fun. Of course, the curtains, heavy velvet. It's hard to see, but you have to trust me. We have a lot of canopies here and also here with the transparent canopies. What's hard to fix in an ancient part, an ancient Liberty villa. Liberty is Italian Art Nouveau. But it was really, really effective. All the focusing effect of dome was completely gone. Here, maybe you can see a little bit more the shape of the canopies. So basically, this is the fact. We have a dome that can focus all the energy in the center of the room, and then in that way, they spread a lot. And this is the final result, with open curtains or closed curtains. Of course, it changed a little bit, so it works like variable acoustics, but in general, the behavior between the mid frequency and the low one is 1.5, so it's good. It's good, it's a good ratio. So, conclusions. The future of acoustic design from my point of view. We have some AI opportunities, so where they can help us really every day. First of all, they can help us to start from a point cloud 3D scan and give us an acoustic modeling. Every acoustic model, every acoustician here can understand what I mean. Why? Because in an hour, you can solve maybe 2 weeks of design with CAD. The second part can be interesting, the material recognition. Why? Because maybe with some way you can have, with some visual and camera stuff and also the probe, you can have some more information about the absorption coefficient of the material itself. But the third one, that in my opinion is the most important part, is the calibration automation. So we made some measurements of the room, and from this measurement, that can be clever enough, 3D, ambisonic, whatever we can do, of course, with AI, with your brain, you have to adjust the model. And this is the main goal for me for the future. So, for small spaces, AI helps with modes, and they can have faster impedance findings. For large spaces, AI can help with complexity and can automatic calibration for alpha values of the room. So less modeling time, more design time, less guessing, more precision, of course. For these reasons, we will start where is a lot of time that we are talking with Florence University, but we will start in 2026 a laboratory for historical indoor acoustics with the University of Florence and also with the Conservatorio, is a School of Classical Music in Florence. Trying to do something new for this kind of stuff, taking the experience from Angelo Farina, which is probably the most important Italian acoustician that disappears last year, that works a lot for this kind of tools like ambisonic microphone and 360 camera, and shows you, probably in a better way than the acoustic camera, what happens in a space, SPL. You can see from each part of the impulse response from where the sounds came, timing, everything. And not less, this is another important point, because in every kind of measurement we use dodecahedron, for example, not for every kind of measurement, but is an omnidirectional source, of course, that spreads the sound everywhere. He was used to work with this MIMO, that is a way to work with a source that has a beamforming in every way. So in the same time, you can measure with a ambisonic measurement microphone with multiple capsules what happens if the beams came from behind, then in another measurement in this, and do a matrix of impulse responses, stimulating the room in different way and capturing the sound with different angles. This can give you a complete idea of what happens in the room. Let's think to put all this experience in a drone and put the ambisonic microphone in a drone and let him make measurement all the night in a cathedral, for example, come back the day after, take the drone. This is the funny part for, of course, the drone makes noise. This is a problem. And this can give you a complete impulse responses of a large space, also going over not only at the listening position. And why I have to measure not at the listening position? Because the measurement doesn't not only help you to understand how is the listening in that position, because we can use this kind of situation, this kind of system to tune the model. So, for example, if we have a big dome like Florence Brunelleschi Dome or maybe Vatican, we need to go on. And it's not easy to go on. For example, when they do the cloud point in Florence Cathedral, they use not a drone, but they have to use a balloon full with the air, because the drone lost the signal to do the 3D scan. And they use a method that also uses Ron Howard to film the movie Angels and Demons in the cathedral. The same technology, and it works. maybe it's a little bit tricky, but so that's the way that we are going to do in the future. Of course, we are an acoustic design firm. We are not a research team, but we try to do something more for the service that we can offer in the future, of course. So thank you. Just remember that in studios we will kill the room. In concert halls we let it sing, but both are right. Okay. Thank you.
Good stuff. Well done.
Thank you.
Está aqui à frente. Não, está aqui.
Clicar aqui para baixo. Tentar não clicar aqui, senão sai. Nós conseguimos
Ok, aqui é para baixo para mudar de slide. Há lá um vídeo. Para pôr o vídeo a andar é para baixo também, se calhar.
Sim, acho que sim.
Vamos experimentar.
Senão voltamos atrás um bocado.
Ok.
Ainda estava aqui. Vou tentar cumprir mesmo o tempo.
Ah, não vai ser difícil cumprir. Acho eu.
Or not. I would like to call to the stage a team that will talk about industrialized construction, new ways of design, new ways to build. I would like to call Joana Neves da Silva from DST and Quito Souza Coutinho from Acoustic.
Hi, hello. I'm Joana Neves da Silva from the ST Group, and I'm a little bit like a fish out of water here today because although I'm a civil engineer and I studied acoustics, I'm far from being an expert, as my colleague over here is. So, but
Rui Calejo.
Well, good afternoon, everyone. I have a big problem. We are the last one. And we are squeezed, stretched between 8 wonderful talks and the sunset cocktail. So I have a very good news to you. We must last only 25 minutes. So that's my best knowledge to you. Well, it's a pleasure of mine to be here. I knew Artnovion since the beginning. I don't know, maybe more than 10 years ago, George appeared in the university and said to me, those 1,000 ideas that he has. And I said to me, George, be careful. The probability to get wrong is very high. And he told me one thing that is most important. This is my family project. And I said, George, yes, you have a chance to run well. He runs very, very, very well. Artnovion is an excellent company. We are going to present now, I suppose. I must present myself. It's not needed. You know a very young guy, 40 years, making acoustic all over the world. Teaching at university, I formed more than 2,000 students. They are not very fond of acoustics, but that's what we have in Portugal. And so that's why I'm here now. And my charge now is to deal the last round table. Guys, round table now. Yes, thank you very much. So that's round table now. Thank you. Well, and I call for the round table. Our lady of this meeting, Joanna, please came to the round table. Otávio, Inácio, you know already it, and Jonathan. Let's say the only guy you don't know in the round table is myself, okay? Because you know all the others. What is supposed to be my place? Pay attention, we have only 25 minutes. Okay. Thank you. 2, 3. It's too much. Well, the boss is here. Okay. So, what is our challenge about this stretched, squeezed round table? Let's talk a little bit about the future. We don't have modular problems. We don't have frequency, low frequencies. We don't have definite elements of Peter. Peter, it was a pleasure to meet you after, I don't know, 30 and so years that we met for the first time. We are going to talk a little bit of philosophy. Philosophy deals what is acoustic and acousticians are used for the humanity. Are we some strange guys that challenge architects for very strange things? Does the humanity want our work? Why do we do our work? What is the purpose of our work? That's what we are going to discuss now. And one very important thing is this. We deal with buildings mainly, okay? Let's focus our attention on buildings. We deal with buildings. There are 2 different kinds of buildings. We have very important buildings, buildings that has the signature of their authors, buildings that are unique in our human heritage. Okay, we are quite challenged to do these works. Big auditoriums, big mosques, big churches, big, I don't know. Okay. Guys, you 3 looking at me, what's happened? Are you afraid of?
We're talking, go ahead.
And we have common buildings. Humanity, let us say, the modern society, what we call the Occidental society. I don't know if the Occidental society is more modern than the others, but the developed society resolved more or less well problems of heat, problems of thermal comfort, problems of food, problems of mobility, problems of health. But when regarding problems of construction, mainly housing, we have a big challenge on cost. New young persons, new boys and girls, They, for all over the world, have big problems in buying their own house. And the houses are becoming smaller and smaller and smaller and smaller, okay? It's common for all Europe. We build houses for one family with 100 and so square meters. And now the first house for young couples has 45 meters, okay? Something is different. What is challenge beneath? For us that are acousticians, it's acoustical behavior. We may have simple houses, but we must have also good acoustics. Because the space is one thing, the privacy and the quality of acoustic is much more important than space. I may not be able to do gymnastics in my room, but I am not able to hear my neighbor regarding sound production. There is a big challenge for us. You say, okay, where broadcasting studios and so on appear. Broadcasting is a very, at world stage, is a very small area, quite expertise, quite challenging. They are not all the same, all different, we know it. Quite challenging, but acoustic for everyone is quite challenging because of cost, because of solutions, okay? That's why to my, I would say my guests, I just placed some previous questions. First, do we have tools to supply acoustics for everyone? Second, the cost challenge, is it possible? Modular construction, off-site construction, is it possible to deliver solutions? And when we need to do what I call a humanitarian architecture, that's what we saw in Abu Dhabi. What we need is humanitarian acoustics, architecture for people, not international standards, okay? We want to see international standards, where do they belong, not to put Eiffel Towers wherever we want, okay? So this is the 3 questions that I'm going to propose to you. 5 minutes for each guy. Sunset is almost beginning. And our audience do not allow you more than 5 minutes. First lady, if you don't mind, Joanna, please.
Okay. Is it working? Yeah. I think we have the tools. Maybe we don't have the money. We don't have the money enough to do everything as it should be done in construction. So, and sometimes some areas are just put apart because it's not that important. The idea is that, okay, the structure is the main part of the building. The facade is an important part of the building because everybody's looking at it. But, and areas like the thermics, acoustics are sometimes left behind, and in the end, that's what people value most when they are using it. Because the comfort of the users, it's mostly because people assume that the building is not going to fall. People assume that it's not going to rain inside the house. But people feel if the inertia, the thermic inertia, is low, and the house is not, and people feel if they can hear the buses passing in the street, and if they hear the neighbors. So one of my fights in our team is to guarantee that we are finding solutions, acoustic solutions, in our system that are going to comply not only to the regulations, but also to comfort standards that we want to reach. Because that's, as Professor was saying, we are doing humanitarian architecture, and we want to reach good solutions and affordable solutions, but that will be a way of maximizing the well-being of the people in the future. And so our goal in this moment is to try to find materials. We are searching also for new materials and trying to find materials that are effective, that are affordable, and that are industrializable. Because in industry, we need to have continuous layers. We don't want to use small tiles or small pieces. We want panels, big panels. And then again, we don't want a lot of layers because the process will be complicated after that. The first floor I wanted to do in our living lab, some people call it the Big Mac floor, because I wanted to test so many layers, because I thought if I don't test it now, I will never test it. So let's put it all, and then we can check what can we take out. So that's our goal now. So I think, answering to your question,
Okay.
we have the tools.
Just one, you said we have the tools, maybe we don't have the money. That's what you said in the beginning.
I think we don't have the money because of course we need to distribute the money on all the areas. And what I feel is that in construction area, usually acoustic is a little bit set apart in what concerns housing. Because in hotels,
No,
designs,
of course. By the way, if you want, last meeting of European Platform on Construction, it was in Paris last July. One of the working groups in which one I was discussing the production cost for housing in Europe. Are you seated? Okay. Nowadays, the production cost, the average, there are some discussion if it is real average or not, but 1,400 euros per square meter. That's the production cost. Production cost is the cost without taxes, without land, and so on. Not selling price, okay? Production for companies. And what is the challenge? Challenge is the United States reference for wooden houses. Production cost, without transportation, $500 per square meter. In Europe, we are fat. We are very fat. We must be thin, okay? That's the challenge. And the challenge is to produce those houses with good acoustics, with good thermal behavior, with durability, and so on. Not to produce inexpensive houses without quality, okay? Very well. Thank you, Joanna.
Can I join the discussion?
Yes, please. That's what you are here for.
Go for it. Because Joanna was talking about the fact that, and I agree with you, that some people, most of promoters and contractors say at a certain point that acoustics, maybe it's not that important, that we can save a lot of money if we don't put it on. But the fact is, and we have to hold on to that as much as we can, at least in Portugal, but I know in other countries the same thing. I talked about that on my presentation. The fact that we have some legislation that says that we have to comply with certain values is the thing that we in our team hold on the most when we are desperate to make sure that we put acoustics in. We just say to the people that are arguing with us, say, okay, you don't want to put it, but at the end, you won't comply with regulations. It is going to be measured, and you don't get a certificate. And at that point, they say, okay, maybe we have to try and minimize, get to the lowest possible value, but at least we have something to hold on to. Yes. And if we lose that, and you know that all the time they're trying to forget about legislation, take it out, it's just a cost. If we lose that, then it will be almost impossible to make sure that people have proper conditions for the housing. As an example, up to a certain, I don't know how many years ago, Brazil, far away from here, they started implementing for the first time criteria for housing, acoustics criteria. And it's actually very low values compared to what we have in Portugal. That. And even in Portugal, there are other countries in Europe that have higher values better values for acoustic criteria. But at least they have something to hold on to. Before they had nothing. So the conditions for housing were really bad in terms of acoustics. So I think that at least if we hold on to that as much as we can, we have something to give to the people that we build houses for.
Okay, Otávio. we are very interested in your relationship with legislation and standards, of course,
And standards,
for
of course.
construction.
Yeah.
But sometimes, and I'm not introducing Jonathan, when we deal with architecture for people, standards are not there. International standards should be different. What's your opinion?
Good question. What is my opinion? So we wrote a book a few years ago in Abu Dhabi called For the People. And it was based on the idea that when the city was designed, it was designed for people. And if you're ever going to design anything, you design for people. It doesn't matter how beautiful the building is and how amazing it sounds. Like if it's not designed for people, like it's just a shell, right? And so every project we do starts with that idea of like, what's the purpose? And that's like a very easy statement to make, but that's the conversation we have with every single client, with every single architect, with every single consultant we work with is like, well, why are we actually building this? What's the reason? And it always comes back to people at the end of the day and how they interact with it. And those are the most important conversations to have at the beginning because they allow us to put in place the kind of values of what that building will be. And then we have to stick to those values. And just back to the first question a little bit, about the tools. I think we have the tools, and where I'm from, we don't have the education about it. We don't have people explaining to us why sound design and acoustic design is really important. And I think that's a key thing that's missing is just people to invest the time, and it takes a long time, but to have those conversations and to sit across from the other clients and the other architects and just explain like, well, this is why it's important and this is why sound makes sense and this is why this space should feel a certain way. And I think that's all part of the same conversation of just making it understandable and making sure the end result benefits the users. I don't know if that answered the question.
Yes, plenty. But I wonder a question. Is there any legislation in Abu Dhabi?
Yeah, for sure. Like specifically about sound and acoustic stuff, there's probably very basic legislation. I'm sure it's at the very beginning, but like everything, it's been built so quickly and it's in such a formative stage that it needs people to go there and actually champion better legislation. And look, I'm sure for every single project that's done, especially those mega projects, there's a sound designer in there somewhere like fighting to be heard and to have legislation created and pushed through. But again, it takes time, and probably there's been legislation that's been tabled and is sitting on a pile of other legislation for building cities, and it just needs the champions to sit there and explain why good sound design, why good acoustics matters. So the basics are there, but there's a lot to build on top of.
Yes, I believe so. I believe so. Well, let's go now forward. We have here some questions from Anonymous. What path should acoustic companies take in order to convince architects of the value of sound design? Maybe, Otávio, you are better on this.
Oh my God, it's a hard question.
What path? A gun?
No. Actually, I think it's the other way around. Because for years, engineers and architects have been battling, confronting ideas and not looking at them from the same perspective. And I probably live in a bubble because the projects that we have, most of the architects we work with, we work together, and it's very easy to cooperate with them. So, but I understand the problems that exists in this confrontation. So we just have to manage, and it comes from us, not from the architects. They're not going to change.
But
we have to make sure that we speak the same language that they do, and try to see it from their way, and then convince them to do it. What we need to do, we need.
We both teach at the university. Don't you think that young acousticians should have a special formation on architecture?
Well, that would be great. I think it's difficult. I think it's a question of culture and common sense and behavior, and making sure that you respect their opinion. You be humble about what you're going to say and what you think about their work, and then try and come together to. Confrontation is never a way to win in this situation.
Another question with my not these glasses. For Joanna, please, what is projected lifespan of construction models and what is recommended maintenance during this period?
The lifespan we are considering now, it's 50 years, but the idea is to make a building that doesn't have a different maintenance from other building. Our buildings are steel structures that will need exactly the same maintenance as a steel structure building that it's done on site. What we are changing is the way we do it. We want we are not making this, we also have some ideas of developing projects of stackable and unstackable modules, but the idea, our system, is to make buildings that will last there, that will be as any other building. The unique difference was that it was made in a factory.
Very well. Another very, very interesting question, maybe the last one from Frank. Okay, that's a very, very interesting question. With all the old buildings in Europe, it is a huge challenge to comply to acoustic legislation, the SCTs, when renovating them. How can we deal with that to meet regulation? Regulation, Octavio, again.
Yeah, well, it's a huge challenge. I can talk you a little bit about our experience here in Portugal and in other countries in Europe that we're working on. And we have to have some compromise. And there are situations where you can't comply and you explain that to the client and you say, here you will have this situation. If you want to comply with this, you will have this extra cost. Maybe we'll have to destroy something that shouldn't be destroyed. So we deal with compromises in this situation. We don't comply completely. We just say maybe there's a margin that we have to decrease in the limits that we have to obey, and in some situations just explain that we can't do it. But if overall we are at least a little bit better than it was, it's a good compromise. But here in Portugal we have a legislation that says that for buildings, old buildings, you have to try and comply as much as you can. You can have 3 dB margin, so below the limits to comply. And if you can't do it, you explain why, and you make the compromise with the owner and with the city hall in terms of licensing and all of that. But it's very hard to do. Yeah, there's no easy reply to this question. Sorry.
Okay, thank you very much. Joanna, Otávio, Jonathan, thank you very much.
Thank you.
We finished this round table here, and you are going out, not yet. You are going on for the final session, yes? Okay, thank you very much for your round table.
Thank you.
Thank you very much.
Thank you.
Joanna.